The universe holds secrets that refuse to fit into any textbook. Far beyond our own Milky Way, a single island of stars, named the NGC 262 galaxy, is a vault of cosmic contradictions. This is not a tour of pretty pictures, but a deep investigation into 50 of the strangest phenomena ever observed. You will gain a front-row seat to discoveries that are actively rewriting the rules of physics. We will encounter a pulsar that vanishes for years, a void that swallows visible light, and a star that seems to manipulate time itself. What does it feel like to stand at the edge of a scientific revolution? Our journey begins with a paradox of perfect timing and absolute silence. Deep within the swirling arms of NGC 262, astronomers once charted a celestial metronome, a pulsar whose radio pulse arrived with such flawless, predictable rhythm that it was considered a cosmic clockwork. For decades, this spinning neutron star broadcast its steady tick across the galaxy, a beacon of cosmic regularity. Then, without warning, it simply stopped. The clockwork failed. For years, the most sensitive telescopes on Earth and in orbit heard nothing but an empty, static-filled silence where that perfect rhythm had been. Then, just as inexplicably, the pulses returned, as steady and strong as if they had never left. This is the phantom pulsar, and its behavior defies everything we know about the violent stability of neutron stars. A pulsar is the ultra-dense, rapidly spinning core of a dead star, and its lighthouse-like beam is powered by immense, unchanging physics. It should not simply turn off. The leading theory suggests the pulsar might be orbiting through a temporary, incredibly dense cloud of debris, perhaps the remnants of a shattered asteroid belt or a companion star it is slowly consuming. This debris could act like a cosmic fog, absorbing or scattering the radio waves before they can escape. But the scale and density required to completely block such powerful emissions for years is staggering, and the debris field would need to be almost perfectly uniform to not cause even a flicker in the signal before it vanished. An even more exotic idea proposes that the pulsar's own intense magnetic field, interacting with a super-dense form of matter at its surface, could occasionally enter a state that traps the energy internally. It is as if the star itself holds its breath for a cosmic interval. Both theories, however, reveal a profound gap in our understanding. Our models of these extreme objects are built on consistency. The phantom pulsar demonstrates that something, whether in its environment or in its very heart, can override that consistency entirely. It forces us to ask a humbling question. Are we observing a strange exception, or is this fleeting silence a normal part of a pulsar's life that we, with our limited human timescales, have simply never caught before? This first mystery sets the tone for everything to come in NGC 262, a galaxy where the fundamental rules seem to be written in pencil, not stone. If the phantom pulsar is a lesson in vanishing signals, the next phenomenon teaches us to distrust our eyes entirely. Within a seemingly quiet quadrant of NGC 262, astronomers observed a background galaxy not simply magnified but fractured. Its light was stretched and smeared into a near-perfect luminous ring that encircled a patch of otherwise empty space. This is a textbook example of an Einstein ring, a cosmic mirage created when the gravity of a massive foreground object warps the fabric of spacetime itself, bending the light from a more distant object behind it like a lens. The ring's perfection was breathtaking, a celestial halo that revealed the hidden geometry of the universe. Yet its very beauty presented an immediate and profound crisis. To create such a flawless circular distortion requires an immense amount of mass at a very specific point in space. The calculations were undeniable. The gravitational lens at the heart of that ring should be equivalent to a supercluster of galaxies, a titanic knot of hundreds of star systems. But when every telescope across every wavelength from radio waves to X-rays pointed at that central point, they saw absolutely nothing. No stars, no galaxies, no glowing gas clouds. Just the profound, empty blackness of space. The lens was there, warping reality with its immense gravity, yet it was completely and utterly invisible. This is the gravity lens mirage, and it is one of the most direct and startling pieces of evidence for dark matter ever observed, but in a configuration that baffles theorists. We already know dark matter exists. Its gravitational pull is what holds galaxies together. But normally, it is thought to exist in a vast, diffuse halo surrounding visible matter. Here, the evidence suggests something radically different, an impossibly dense, isolated knot of pure dark matter, a phantom supercluster with no stars to call its own. It is as if you saw the perfect, circular ripples from a stone dropped in a pond, but when you looked for the stone, you found only empty water. How does such a dense concentration of dark matter form without triggering the birth of a single star? Could it be the ancient, cold remnant of a cosmic event so violent it stripped away all normal matter, leaving only the invisible gravitational scaffolding behind? Or is this a glimpse of a different kind of dark matter altogether, one that can clump and structure itself in ways our models never predicted? The empty space at the center of that luminous ring is a silent challenge, a gravitational signature without a source, reminding us that most of the universe's mass does not play by the rules of light. This absence of light is not the only way NGC 262 hides its true nature from our eyes. Just a few thousand light years from the invisible gravity lens, another cosmic blind spot defies explanation. Observers call it the chromatic void, a perfect sphere of absolute blackness drifting through one of the galaxy's spiral arms. Point the most powerful optical telescope at it, and you see nothing but a hole punched in the starfield, a patch of space so dark it seems to swallow starlight whole. Yet this void is not empty. Switch your view to the ultraviolet spectrum, and the same region erupts into a furious, violet-hued nebula swirling with intense energy. Look again in infrared, and it glows with a deep, warm crimson heat. This sphere absorbs every single photon of visible light that enters it, while blazing brilliantly in colors our eyes can never see. It is a cosmic chameleon, visible only through technological extensions of our senses. The immediate suspicion, of course, is dust. Interstellar dust clouds are excellent at blocking blue light, making distant stars appear redder. But to completely extinguish all visible light across such a vast, perfectly spherical volume would require a dust cloud of unimaginable density and uniformity. A wall of grit so thick it should also block the very ultraviolet and infrared light the void emits. That it does not is the central paradox. One compelling theory suggests this is not a cloud at all, but a bubble. Imagine a supernova shockwave or the powerful stellar wind from a massive star pushing outwards for millions of years, sweeping up all the surrounding gas and dust into a thick, dense shell. We would be looking at the interior of that bubble, a cavity lined with material that filters light in a bizarrely selective way. The shell itself, heated by embedded stars or residual energy, could glow in ultraviolet and infrared, while its precise composition acts like a perfect filter for the visible spectrum, letting nothing through. An even more radical idea ventures into the realm of altered physics. Could there be a localized phenomenon within that bubble, a place where the fundamental constants related to light's interaction with matter are subtly different? It is a staggering thought that the rules governing how light travels and is absorbed might not be uniform across the universe, but could have tiny patchwork variations. While this remains highly speculative, the chromatic void forces it onto the table. This is not merely an object we do not understand. It is a filter placed between us and reality, teaching us that the universe we see in photographs is only a narrow slice of a much richer, stranger electromagnetic landscape. What other wonders, we must wonder, are hidden in the colors we cannot perceive? The chromatic void teaches us that seeing is not believing, but what happens when the universe itself begins to beat like a heart. Drifting through the same galactic arm, a vast cloud of glowing gas presents a spectacle of impossible rhythm. This is the resonant nebula, a celestial tapestry of hydrogen and dust that should by all rights be a scene of beautiful chaos. Nebulae are stirred by the violent winds of newborn stars and the shockwaves of ancient explosions, their light a flickering, uneven glow, yet this particular cloud pulses. Not with random twinkles, but with a deep, synchronized wave of light that sweeps across its entire multi-light year structure once every 17.3 Earth hours. It is as if the nebula itself is breathing in and out, or ringing like a single gargantuan bell struck by an invisible hand. This coordination is the central mystery. The gases in a nebula are tenuous, with particles often light years apart. For a pulse of light to travel across the entire structure would take years, not hours. There is no way for one side of the nebula to know what the other side is doing through normal means. It defies the basic physics of communication, like a crowd of people spread across a continent suddenly clapping in perfect unison without any signal. The implication is staggering. Something is influencing every particle within the nebula simultaneously, creating a standing wave of energy that makes the entire cloud resonate as one entity. Astronomers have desperately searched for the conductor of this cosmic orchestra. Is there a hidden, pulsing neutron star at its core, bathing the nebula in rhythmic bursts of radiation? The search has turned up nothing with the right tempo. Could it be the gravitational influence of a binary star system, its orbital dance somehow imprinting a rhythm on the surrounding gas? The required energy and precision seem far beyond any known celestial mechanics. This has led theorists to consider forces we rarely invoke at such scales. One compelling, though highly speculative, idea involves magnetic fields. Imagine the nebula is threaded by a primordial magnetic field, a fossil relic from the galaxy's formation. If this field were somehow plucked or excited, perhaps by a passing shockwave eons ago, it could begin to vibrate at a specific frequency. Every charged particle in the nebula, coupled to this vibrating field, would then move in lockstep, causing the synchronized glow we observe. It would be a form of communication faster than light, not through particles, but through a coordinated shift in the underlying field that connects them. Another, even more profound possibility touches on a fundamental mystery of quantum physics: entanglement. On a subatomic scale, entangled particles can affect each other instantly across any distance. This phenomenon is fragile and has never been observed at macroscopic scales, yet the resonant nebula forces a haunting question. Could the extreme conditions of a nebula's birth, a moment of incredible density and energy, have left its vast cloud of particles in a subtle, large-scale entangled state? What we are witnessing would then be a cosmic-scale quantum phenomenon, a single wave function describing light years of gas oscillating as one. While this remains a fringe hypothesis, its mere consideration highlights how deeply this simple, rhythmic pulse challenges our understanding. The nebula is not just a cloud, it is a single, coherent object singing a note we are only beginning to hear. Its steady, silent pulse in the darkness of NGC 262 asks us what else in the cosmos might be connected in ways we cannot yet see, bound together by forces that operate outside of time and space as we know them. The rhythm of the resonant nebula hints at hidden connections, but in another corner of NGC 262, a trio of star systems clustered in the triangulum sector present a different kind of puzzle. Here, the laws of stellar life, orbital mechanics, and planetary behavior are not just bent, but rewritten in three distinct and bewildering ways. The first, known as the Lazarus binary, features two stars locked in a gravitational dance. One star behaves exactly as expected, steadily burning through its fuel and aging. Its companion, however, is doing the impossible, Detailed observations over decades show its spectral signature, the chemical fingerprint of its atmosphere, actually growing younger. The ratios of heavier elements to lighter hydrogen are decreasing, a process that defies the fundamental arrow of stellar time. Stars are not like living creatures, they cannot grow younger. They fuse hydrogen into helium and then into heavier elements in a one-way journey. For a star to appear to reverse this process suggests something is actively replenishing its outer layers with fresh, pristine hydrogen. The leading theory is a form of stellar vampirism taken to an extreme. The aging star may be siphoning its own enriched material onto the younger one, but in such a delicate, sustained flow that it dilutes the younger star's atmosphere faster than its own core can pollute it. It is a cosmic fountain of youth, with one star sacrificing its own future to rewind the clock for its partner. Yet, the precision required for this balance is almost inconceivable, forcing astronomers to question if we are witnessing a fleeting, million-year moment in a stellar relationship or a stable state that could last for eons. Just a few light-years away, the second anomaly offers a spectacle of celestial choreography. A system of 6 planets orbits a quiet orange dwarf star. Their orbits do not simply trace ellipses, they perform an intricate, synchronized dance. Each orbit slowly rotates or precesses like a hula hoop spinning around a dancer's waist. This precession is normal in small amounts, caused by gravitational tugs from other bodies. Here, however, the precession of all 6 orbits is locked in a perfect geometric ratio. As one orbit completes 3 full rotations, another completes exactly 2, and another exactly 5, creating an ever-shifting, perfectly predictable model of gravitational harmony. This is a natural orrery of stunning precision. Such resonant orbits are known in our own solar system in simple pairs, but a 6-body harmonic lock of this complexity is unprecedented. It suggests this system formed in an environment of unbelievable calm and stability, untouched by the gravitational bullying of passing stars for billions of years. It is a pristine fossil of planetary birth, a clockwork solar system that has ticked with perfect symmetry since its creation. The existence of this harmonic clockwork raises a profound question about our own cosmic neighborhood. Is our solar system, with its occasional chaotic shifts and historical planetary migrations, the norm, or is it the messy outlier? The final member of this trio shatters the quiet of deep space with artificial-seeming noise. Drifting alone in the dark between these strange star systems is a rogue planet, a world without a sun. This frozen, isolated sphere should be a silent tomb. Instead, it is a lighthouse. It emits powerful, focused bursts of radio energy. These are not the random crackles of auroras or lightning, but structured pulses with a complex, repeating pattern that defies easy classification. The pattern is not a simple mathematical sequence, but it is also not truly random. It possesses a statistical signature that sits uncomfortably between natural phenomenon and constructed signal. The debate it sparks is immediate and fierce. Could this be the natural product of a planetary core with an unimaginably powerful and dynamic magnetic field, perhaps one churned by tidal forces from a hidden moon or a recent cataclysm? Or does this lonely world, broadcasting its intricate code into the eternal night, represent something else entirely? The very question forces us to confront the line between the supremely unusual and the intentionally designed. This solitary beacon, floating near 2 other systems that break the rules of time and motion, makes the Triangulum sector feel less like a random patch of space and more like a gallery of cosmic impossibilities. What if these 3 anomalies are not separate curiosities, but pieces of a single, larger puzzle we have not yet learned to see? The lonely radio beacon of the rogue planet forces us to question the very fabric of connection, and in NGC 262, that fabric may not be a metaphor. Spanning the dark gulf between two stellar nurseries, astronomers have mapped a structure so delicate and so strange it seems to belong to a different universe. They call it the quantum filament. To the unaided eye, it would be invisible, a ghostly thread thinner than a solar system is wide. Yet, this filament of superheated plasma stretches for over 400 light-years, a cosmic wire strung across the void. Its existence alone is a marvel of stability, as such a slender structure should dissipate into the surrounding chaos in mere millennia. But its true mystery lies not in its persistence, but in its behavior. Instruments monitoring each distant end of the filament record a bizarre synchronicity. A flare of energy at the western terminus is matched with no measurable delay by an identical fluctuation at the eastern end, hundreds of light-years away. The information or the influence appears to travel instantaneously. This is not supposed to happen. According to Einstein's theory of relativity, nothing can travel faster than light. A signal crossing that distance should take centuries. What we are witnessing mirrors a phenomenon from the subatomic world, quantum entanglement, where two particles become linked so that a change to one immediately affects the other, regardless of distance. But that is a fragile connection, typically destroyed by any outside interference. The quantum filament suggests this spooky action at a distance might be happening on a scale encompassing trillions of particles, all maintaining a coherent link across interstellar space. The implications shudder through modern physics. One explanation is that we are seeing a cosmic-scale quantum object, a single wave function describing an entire strand of the galaxy. This would mean the rules governing the very small do not break down at large scales, but can, under the right conditions, manifest in structures we can actually see. It would be like discovering that a single thought could be spread across an entire city, with every person simultaneously aware of it. A less revolutionary but equally mind-bending theory proposes the filament is a topological defect, a crack or wrinkle in space-time itself left over from the galaxy's violent birth. Think of it like a flaw frozen into glass as it cools. This defect could create a shortcut, a wormhole-like connection that functionally makes the two ends adjacent in a higher dimension, allowing effects to bypass normal space. The filament would not be a thing in space, but a feature of space. Both ideas force a profound re-evaluation. If it is quantum, our understanding of reality's scale is incomplete. If it is a defect, our universe may be threaded with invisible shortcuts and scars from its creation. The quantum filament is more than a celestial curiosity. It is a direct challenge, a line drawn across the heavens that asks whether the deepest laws of the tiny quantum realm are secretly woven into the grand architecture of the cosmos. This thread of quantum connection is not the only place where the normal flow of events seems to unravel. Deep within a globular cluster orbiting NGC 262, a solitary star presents a riddle written in the very color of its light. Astronomers have named it the chronometric star, and watching it is like observing a clock that cannot decide how fast to tick. The light we receive from this star does not hold a steady color. Instead, it rhythmically stretches toward the red end of the spectrum, then compresses toward the blue in a rapid, pulsing cycle. This shift, known as redshift and blueshift, is the standard tool for measuring motion. A star moving away from us shows redshift, its light waves stretched. A star approaching shows blueshift, its light waves compressed. The chronometric star, however, is not orbiting anything we can detect. It is alone. Its light is changing color as if the star itself is racing toward us and then away from us, over and over, at impossible speeds without actually going anywhere. The only explanation that fits this bizarre data is that time itself is not flowing at a constant rate in the space surrounding this star. Imagine you are listening to a steady drumbeat. If the drummer moves away from you, the beats arrive farther apart, the rhythm slows. If the drummer moves toward you, the beats crowd together, the rhythm speeds up. Now imagine the drummer is standing perfectly still, but the very air between you is somehow stretching and compressing, altering the speed of sound to create the same effect. That is what appears to be happening with light around the chronometric star. The fabric of space-time seems to be breathing, causing time to alternately dilate and contract from our distant vantage point. This makes it a living, breathing laboratory for testing the extreme limits of Einstein's theory of relativity. One model suggests the star is at the heart of an incredibly dynamic and complex gravitational field, perhaps due to the dense, invisible mass of the surrounding globular cluster warping space-time in a rapidly oscillating pattern. It is as if the star sits at the center of a trampoline that is being shaken from below, making the dimples in the fabric ripple around it. Another, far more speculative idea ventures into realms of theoretical physics we can barely comprehend. Could this star be interacting with a hypothetical dimension where time behaves like a physical substance? In our normal 3 dimensions of space and 1 of time, we move freely through space but are carried inexorably forward through time. Some theories suggest there could be additional, curled-up dimensions, including ones where time-like properties exist. If the chronometric star's immense gravity or some unique property of its matter is briefly brushing against such a dimension, it could cause localized tremors in the flow of time we experience. While this sounds like science fiction, the observed data demands explanations that sound exactly that way. This star is not just an object in space, it is a disturbance in time. Its rhythmic, colored heartbeat challenges our most fundamental experience of reality, the steady, reliable forward march of moments. If time can ripple like water around a single star, what does that say about the stability of time everywhere else? This strange dance between time and light finds a chilling parallel in the relationship between the seen and the unseen. While the chronometric star warps time, another region of NGC 262 presents a stark divorce between the 2 fundamental components of our universe. Drifting in the galactic halo is a colossal molecular cloud, a stellar nursery so vast it could birth 1,000 solar systems. Yet within its swirling depths, astronomers have mapped a pattern that should not exist. They call it the anti-correlation cloud. Here, the map of normal matter, the glowing hydrogen gas, the specks of dust, the potential seeds of future stars paints one picture. The map of dark matter, inferred through its gravitational pull, paints the exact opposite. Where the cloud of normal gas is thickest and densest, the dark matter is faint and diffused. Where the normal matter thins out into wispy tendrils, the dark matter pools into intense, invisible knots. This is a direct one-to-one anti-correlation, a cosmic seesaw where one side goes up precisely as the other goes down. This discovery strikes at the very heart of how we believe galaxies are built. For decades, the standard model of cosmology has been clear: dark matter comes first. Its invisible gravitational scaffolding forms first in the early universe, creating vast web-like structures. Normal matter, the atoms that make up stars, planets, and us, is then drawn by gravity into these dark matter halos. It clumps where the dark matter clumps. They are cosmic partners, with dark matter as the guiding framework and normal matter following its lead. The anti-correlation cloud turns this partnership into a rivalry. It shows a region where normal matter has actively gathered in places dark matter has vacated, or where dark matter has been pushed out by the presence of normal matter. It is as if you walked into a library expecting to find the most people in the sections with the most bookshelves, but instead found the crowds gathered in the empty reading nooks, while the shelves stood alone in silent, abandoned halls. What force could possibly cause this separation? Gravity alone cannot do it. Gravity only attracts. One compelling theory involves the raw, violent energy of star formation itself. Imagine this cloud beginning its life with the normal dark matter partnership. Then, in the densest pockets of normal gas, the first massive stars ignite. These stars do not just shine, they flood their surroundings with intense radiation and powerful stellar winds, a hurricane of energy that pushes against the surrounding gas. This normal matter can be heated and swept away. Dark matter, which does not interact with light or radiation at all, feels no such push. It remains unaffected by the stellar fury. So, in this scenario, the normal matter is being blasted clear of the dark matter knots, creating the observed anti-correlation. The dark matter is left behind like a ghostly outline of where the action once was. But there is a problem with this elegant idea. The scale and perfection of the anti-correlation are extreme. The stellar winds would need to be improbably uniform and powerful to create such a clean, galaxy-wide separation. This has led to more radical suggestions. Could dark matter possess a property we have never detected, a way to interact with itself that is repulsive under certain conditions? If dark matter particles can sometimes repel each other, then the crowding of normal matter might create an environment that triggers this repulsion, pushing the dark matter away. An even more mind-bending possibility is that we are witnessing the aftermath of a direct interaction between dark matter and an unknown force or particle, one that is somehow tied to the density of normal atomic material. The anti-correlation cloud is not just an oddity, it is a controlled experiment written across light years. It presents two ingredients that should mix, showing us instead that they actively separate. This forces a profound question upon cosmology. Is dark matter truly just a passive gravitational scaffold, or can it, under the right conditions, engage in a dynamic and complex dance with the visible universe, a dance that includes steps of avoidance and flight? The map of this cloud is a clue to a relationship far more complicated and far more interesting than we ever imagined. The map of dark matter's strange avoidance leads us to a place where the universe's oldest light simply disappears. In a remote sector of NGC 262, astronomers have found a window into a deeper, colder darkness. This is the symphony of silences, a region of space where the cosmic microwave background, the faint afterglow of the Big Bang itself, is not just dimmed but entirely absent. It is a cold spot of staggering perfection, a patch of sky that plays a perfect, absolute silence against the universal hum of creation. Every direction we look, the cosmos is filled with this primordial whisper, a uniform bath of microwave radiation that is the cooled remnant of the universe's fiery birth. Yet here, in this one specific direction, the signal drops away to nothing. It is as if someone has placed a cosmic mute button over a section of the sky, silencing the echo of the beginning. This is not a minor fluctuation. This cold spot is vast, spanning a width hundreds of times larger than our full moon, and its temperature is profoundly, inexplicably lower than the surrounding background. The most straightforward explanation within our standard model of cosmology is a supervoid, an immense bubble of space that is mostly empty of galaxies and galaxy clusters. As light travels through such an underdense region, it can lose energy, stretching to longer, cooler wavelengths in an effect called the integrated Sachs-Wolf effect. Think of it like rolling a marble up a gentle hill. It loses speed and energy as it climbs, but there is a devastating problem with this simple idea. For the observed cold spot to be caused by a void, that void would need to be so absurdly large, so profoundly empty, and positioned at such a precise distance that it defies the statistical predictions of our best models of cosmic structure. It would be a cosmological anomaly of such magnitude that it is nearly as puzzling as the cold spot itself. The scale required is cosmologically problematic, meaning it should be incredibly, almost impossibly rare in a universe governed by the laws we know. This failure of the simple void theory has opened the door to speculations of breathtaking scope. One of the most profound ideas is that this cold spot is not a feature within our universe, but a scar from an encounter with another. In the theory of eternal inflation, our entire cosmos is one bubble in a frothing, infinite multiverse. Other bubble universes with different physical laws are constantly budding off. According to this model, if two such bubbles had brushed against each other in the distant past, Their collision would leave an imprint on the cosmic microwave background, a circular region of altered temperature. The symphony of silences could be the bruise from that primordial contact, a place where the energy of our universe's field interacted with the alien field of another. We would be looking at the fingerprint of a cosmos that is not our own. The silence, then, is not an absence but a message. It is the acoustic shadow of an event that happened before time, as we know it, had meaning. Whether it is a freakishly vast emptiness or a window into the multiverse, this profound quiet in NGC 262 forces us to confront the limits of our cosmic map. We are left listening to a silence that speaks volumes about what might lie beyond the edges of everything we see. The profound silence of the cosmic background gives way to a spectacle of unimaginable violence. Drifting through the outer reaches of NGC 262 is a gas giant of such staggering scale and ferocity that it redefines the word storm. This is the world known as the metallic megastorm, a planet where the sky is not made of gas but of an ocean. Beneath a thin, superheated atmospheric shell, pressures rise to such insane levels that hydrogen itself undergoes a radical transformation. It ceases to be a gas and becomes a liquid metal, a swirling, electrically conductive sea that stretches down to the planet's core. This churning metallic ocean is the engine for a meteorological hellscape beyond anything in our solar system. Here, storms are not temporary events. They are permanent, continent-sized vortexes of liquid metal, raging for millennia. We cannot see them with optical telescopes, for the planet's upper atmosphere is opaque and dark. But in the X-ray spectrum, this world blazes like a furious beacon. The titanic friction within those metallic whirlpools, the sheer kinetic energy of continent against continent in a fluid form, generates temperatures in the millions of degrees, causing the planet's face to glow with a harsh, high-energy light. It is a permanent, planet-wide aurora born from pure atmospheric violence. This ceaseless churning does more than just glow, however. It forges a magnetic field of incomprehensible power. In our own Jupiter, the dynamo effect, the motion of conductive metallic hydrogen deep within, creates a mighty magnetic field. The metallic megastorm operates on a principle 1,000 times more intense. Its entire atmosphere is the conductor. Those permanent, continent-sized storms are not just weather, they are planet-scale electrical generators. Each massive vortex acts like a turbine in a cosmic power plant, spinning rivers of liquid metal through the planet's own intrinsic magnetic field. This motion induces colossal electrical currents, which in turn amplify the magnetic field to ludicrous levels, which then allows for even stronger currents. It is a self-reinforcing feedback loop of electromagnetic might. The resulting magnetic field is so powerful that it visibly shapes space around the planet, trapping and accelerating charged particles into belts of radiation that would vaporize any spacecraft in an instant. The mystery for astrophysicists is not that the planet has a magnetic field, but that its strength violates every known model for planetary dynamos. Our equations, built to explain Jupiter and Saturn, break down completely when applied to the readings from this world. The energy output is simply too high. The system should tear itself apart or settle into a quieter state. The fact that it does not suggest a fundamental ingredient is missing from our understanding of hyper-dense matter in motion. Could the liquid metallic hydrogen here possess a different, more efficient form of conductivity under these extreme pressures? Or is the very geometry of the storms, their number, their arrangement, their depth creating a perfect resonance, a natural harmonic that amplifies the magnetic field to these impossible levels? This planet is more than a world. It is a natural particle accelerator and a laboratory for states of matter that cannot be recreated on Earth. Its permanent X-ray glow is a signature of forces so raw they bend the rules of planetary science, proving that under enough pressure, even the simplest element in the universe can transform into the foundation for a permanent, electrified maelstrom. The raw, elemental fury of the metallic megastorm is a whisper compared to the titanic forces at play in the very heart of NGC 262. Here, in the galactic core, gravity achieves its ultimate expression, and the rules break down completely. We find not one, but two supermassive black holes locked in a gravitational duel, each presenting a unique and impossible signature. The primary black hole, a monster with the mass of billions of suns, is a known source of relativistic jets. Twin beams of matter and energy shot out at nearly the speed of light from its poles. These jets are not steady. They slowly wobble or precess, tracing a vast circle in the sky over an 11-year cycle. This is phenomenon 13, a cosmic clock of staggering precision. The problem is, a black hole's jet precession is almost always caused by the gravitational tug of a nearby companion, like a spinning top wobbling because another top is orbiting it. Yet, despite exhaustive searches, no such companion can be found. There is no second supermassive black hole in a close orbit, no massive star cluster, nothing with enough gravity to pull on this behemoth and make it wobble with such perfect 11-year regularity. It is as if the universe has set a metronome ticking in the darkness, but hidden the hand that winds it. One theory suggests the companion is there, but it is itself a black hole shrouded in an impossibly thick, spherical cloud of cold, dark matter that emits no light we can detect. This dark matter halo would have to be perfectly smooth and stable to not betray its presence through stellar motions, yet dense enough to exert the precise pull needed. Another, more unsettling idea is that the precession is not external at all, but internal. Could the black hole itself be asymmetrical? Our models assume these objects are perfect spheres, defined only by their mass, spin, and charge. But what if, in its formation, it acquired a slight lumpiness, a density variation frozen into its very structure? As it spins, this asymmetry could cause its jets to wobble like a poorly thrown football. This would mean our fundamental picture of a black hole's simplicity is wrong, that they can carry the fossil imprints of their violent birth. The 11-year cycle is a ticking clue, a rhythm in the chaos pointing to a hidden architecture we do not yet understand. Its dance partner, the smaller secondary black hole, presents a mystery that resonates through the fabric of spacetime itself. Phenomenon 14 is a quiet, constant hum detected not by telescopes, but by the subtle stretching of space. This black hole's event horizon, the point of no return, does not appear as a static boundary. Instead, it ripples. Advanced gravitational wave observatories have detected a constant, pure frequency wave emanating from it, a signature that matches a standing wave pattern on its surface. This is the unmistakable fingerprint of a binary system, two massive objects orbiting each other so closely that their gravitational interaction distorts their very shapes, sending out a steady signal. The frequency is constant, meaning the orbit is stable. They are not spiraling inward to merge, as all known black hole binaries eventually do. They are locked in a perfect, eternal dance. Yet, once again, we see only one partner. The secondary black hole appears to be waltzing with a ghost. The object causing these ripples is utterly invisible, not just to light, but seemingly to any form of detection except gravity itself. This has led to one of the most provocative hypotheses in modern astrophysics. The black hole may be orbiting a primordial black hole. These are hypothetical objects thought to have formed not from dying stars, but from the intense pressures of the Big Bang itself. They could be almost any size, from a mountain's mass to a planet's, and would be composed of pure, dense matter, emitting no light or radiation. A primordial black hole of sufficient mass, orbiting just outside the secondary black hole's event horizon, could create this exact stable, humming binary. It would be a fossil from the first second of the universe, forever bound to a later-born giant. Alternatively, the partner could be something even stranger, a stable knot of dark matter so dense it acts like a point mass, or an exotic stellar remnant made of theoretical particles like strange matter. Whatever it is, this unseen object is teaching us a profound lesson. Its gravitational waves are a language, a direct transmission of information from the edge of reality, telling us that the most powerful relationships in the cosmos may be between things we can see and things we can only feel. The dueling black holes at the core of NGC 262 are not just destroying matter, they are revealing the hidden choreography of the universe, a dance set to the rhythm of an 11-year wobble and the eternal hum of a ghostly partner. This ghostly gravitational hum is a whisper against a more visible and more perplexing cosmic migration. Orbiting a quiet red dwarf star in the galaxy's outer suburbs, a vast belt of icy bodies presents a contradiction frozen in motion. This is the crystallized comet swarm, a collection of thousands of objects that look and act like classic comets, drifting in the deep freeze of their system's outer reaches. They follow elongated orbits, and when nudged inward, they blossom with glorious tails of gas and dust. Yet, when astronomers analyze the light reflecting off their dark surfaces, they find a signature that shatters expectations. Their spectra scream not of primordial ice and simple organics, but of complex crystalline minerals. We are seeing the fingerprints of olivine, pyroxene, and other silicate crystals that, on Earth, are born in the searing heat of volcanoes or the hearts of forging asteroids. These minerals can only form when rock is melted and then cooled slowly under sustained, intense heat. It is the geological signature of a furnace, and that is the profound mystery. These comet-like bodies reside in a region of space so cold that temperatures hover just a few degrees above absolute zero. It is the last place in the universe you would expect to find a freshly forged crystal. The cold out there is so deep and still that any heat from their formation billions of years ago should have bled away into the void eons ago, leaving their surfaces as dead and unchanged as a stone in a glacier. So why do they gleam with the mineralogical signature of a recent fire? One compelling theory is one of cosmic theft. Perhaps this entire swarm did not form here in the cold dark, but was violently kidnapped. The parent star, the red dwarf, may have had a close gravitational encounter with another star system in the distant past. During that stellar flyby, the star could have ripped away a collection of asteroids from the inner, hotter region of its neighbor's system, flinging them into its own distant, frozen grip. These captured asteroids, already baked and crystallized by their close orbit to their original sun, now masquerade as comets, their icy surfaces a later accumulation of frost over a warm, stony heart. This is a story of celestial piracy written in crystal. The problem is one of probability, for the captured objects to not only be numerous enough to form a vast belt, but to also all share this same heated history strains belief. It would require a perfectly targeted heist of already processed material. This improbability fuels a more startling and more transformative idea. What if the heating is not a memory but an ongoing process? What if these distant icy bodies are not cold at all inside? The leading hypothesis here is tidal heating, but on a scale and with a mechanism we have never seen. In our own solar system, Jupiter's moon Io is kept molten by the constant gravitational kneading of Jupiter and its sibling moons. Could something similar be happening to each of these thousands of comet-like objects? For tidal heating to work, you need a powerful, changing gravitational pull. Perhaps each of these bodies has an unusually dense, rocky core and is locked in a complex orbital resonance with a hidden, massive planet further out. The rhythmic gravitational tug of war could flex the core of each object, generating immense internal friction and heat. This heat would then slowly percolate upward, warming the base of the icy crust and allowing for the slow recrystallization of minerals near the surface. They would be icy on the outside, with tails of vapor, but geologically alive with a warm, rocky heart underneath, a kind of cryovolcanic engine powered by an invisible giant's dance. An even more exotic possibility involves the decay of radioactive elements. but for that to provide enough sustained heat billions of years after the system's formation, these objects would need to be improbably rich in elements like aluminum-26 or iron-60, isotopes that were abundant in the early solar system but decay quickly. It would mean they formed from a uniquely hot batch of primordial material, a pocket of the nebula that was unusually enriched with stellar ashes, and then were all herded together into this distant belt, a preserved enclave of the system's most radioactive leftovers. The crystallized comet swarm forces us to abandon the simple idea that comets are always pristine, icy time capsules. Here, they may be geological diaries, their crystalline surfaces recording either a violent journey across space or a hidden, warm vitality stirring beneath the ice. They ask whether the boundary between a dead, frozen rock and a living, heated world is far thinner and far more common than we ever dreamed. The warmth of crystallized comets gives way to a whisper from the dawn of time itself. Woven through the hydrogen clouds of a specific spiral arm, a faint, pervasive radio signal haunts the listening instruments of astronomers. This is not the crackle of pulsars or the hiss of background radiation, but something far more profound, the echo of creation. Its frequency signature is unmistakable, matching the precise theoretical prediction for the first generation of stars ever born in the universe. Astronomers call these mythical giants population 3 stars. They were behemoths hundreds of times more massive than our Sun, forged from nothing but the pristine hydrogen and helium that emerged from the Big Bang. Their lives were brilliant and brief, ending in colossal supernovas that seeded the cosmos with the first heavy elements, the carbon, oxygen, and iron that would later build planets and life. According to all our models, the last of these primordial titans died over 13 billion years ago. Their light should have faded into the cosmic background eons ago, a fleeting chapter lost to the expanding universe. Yet here in NGC 262, their song is still playing. Detecting this signal is like walking into a modern concert hall and hearing, clear as a bell, the very first note ever played on a violin, centuries after the instrument shattered. The impossibility is absolute, so how can we be hearing the echo of a dawn that vanished before our galaxy even fully formed? One theory is as beautiful as it is complex, a gravitational echo chamber. Imagine the region where this signal originates is not just empty space, but a perfect cosmic cavern. At its heart, long ago, a cluster of those first stars did indeed blaze and die. But their light did not simply fly off into the void. Instead, it became trapped. The immense gravity of the cluster's remnant, a dense knot of dark matter and dead stellar cores, could have bent space-time around itself so severely that it created a closed loop for photons. The light from those ancient explosions has been racing in a giant, circular path for billions of years, completing lap after lap around this gravitational well. Every so often, a tiny fraction of this trapped light leaks out, reaching our telescopes as a faint, repeating signal from the past. We are not seeing the stars themselves, but their final flash, forever cycling through a prison of curved space. It is a fossil of light on an endless marathon. The other theory is even more staggering in its implications. Perhaps this is not an echo at all, but a new performance. Could this spiral arm be a rare cosmic relic, a pocket of the universe that somehow preserved the pristine conditions of the early cosmos? Within this vast cloud, maybe the gas never mixed with the heavier elements from later supernovas. It remained pure hydrogen and helium, a preserved bubble of primordial soup. Then, billions of years after everywhere else had moved on, this cloud finally collapsed under its own gravity and did the impossible. It forged new stars that are, in their chemical composition and immense size, perfect replicas of the first generation. We would be witnessing a second genesis, a reboot of cosmic history in a forgotten corner of a modern galaxy. This idea challenges the linear narrative of cosmic evolution, suggesting that under the right, miraculous conditions, the universe can accidentally recreate its own beginnings. Either answer reshapes our understanding. If it is an echo chamber, it means the architecture of space-time can preserve specific moments from the dawn of time with near-perfect fidelity, offering us a direct window to witness creation. If it is a second genesis, it means the recipe for the first stars is not lost, and that the universe may still hold untouched sanctuaries where the clock was reset to zero. The faint radio whisper in that spiral arm is more than a signal. It is a question written in the language of hydrogen. Are we listening to a ghost, or are we witnessing a miracle? That faint echo from the dawn of time is a whisper against a current of raw, visible power. Arcing across a starless void between two distant, lonely suns, a bridge of pure energy defies the emptiness. This is the flux transfer arc, a river of incandescent plasma so brilliant it outshines the stars it connects. Picture two islands separated by an ocean of night, suddenly linked by a permanent, shimmering aurora. The two stars are not a close binary. They are light years apart, far too distant for any normal gravitational bond. Yet between them, this luminous highway persists, a conduit through which matter and magnetic influence flow in a continuous, titanic exchange. One star, a vibrant blue giant, appears to be slowly bleeding its atmosphere away. Streams of superheated gas flow down the arc like water down a glowing aqueduct, feeding its quieter, orange companion. This alone would be a stunning spectacle, a stellar transfusion across the void. But the arc is not just carrying gas. Instruments reveal it is crackling with magnetic energy, a flux tube of unimaginable scale that is transferring the blue star's furious magnetic field directly into its partner, fundamentally altering the smaller star's activity and rotation. The existence of such a stable structure over light years of empty space is a profound violation of known physics. Plasma in a vacuum wants to dissipate, to expand and cool into invisibility. A column of it, even if somehow created, should blur and vanish within days, not persist for the centuries we have observed. Something is holding this river of fire together, containing it with walls of pure force. The only candidate powerful enough is magnetism. The arc must be sheathed in a magnetic field of impossible strength, a tube of force so coherent it acts like an invisible pipeline, keeping the plasma focused and flowing. The problem is the energy required to generate and sustain such a field across interstellar distances is more than the combined output of both stars for their entire lifetimes. It is as if the stars are not generating the field themselves, but are simply tapping into a pre-existing structure, like two towns connected by a pre-built superhighway. This leads to the most radical explanation. The arc is not a natural formation of the stars, but a visible manifestation of something far more exotic, a cosmic string. In theoretical physics, cosmic strings are hypothetical, one-dimensional defects in space-time, infinitesimally thin but possessing immense mass. They are cracks in the fabric of reality, left over from the universe's rapid cooling after the Big Bang. If such a string passed near or through these two stars, its unimaginable gravitational and magnetic influence could have captured plasma from their atmospheres, lighting it up like a neon sign tracing its invisible path. The stars did not build the bridge. They are merely accidental lanterns hanging from a cable that was strung across the cosmos at the beginning of time. The flux transfer arc, then, is more than a beautiful anomaly. If it is magnetic, it reveals a form of stellar interaction and energy transfer we never thought possible, a direct, tangible link between distant suns. If it is a cosmic string, it is our first glimpse of the primordial architecture of the universe, a fossil from creation so powerful it can stitch stars together with threads of fire. This luminous arc forces a choice between two impossibilities, a magnetism that bends the laws of energy, or a ghost from the Big Bang made visible. The luminous arc of the flux transfer arc speaks of connections forged by raw physics, but in the quiet light of a distant sun, a different kind of signature hints at a connection of profound intimacy. Orbiting a stable yellow star in one of NGC 262's outer arms, a rocky world passes regularly between its sun and our telescopes. Each transit is a celestial gift as the star's light filters through the thin, hazy envelope of the planet's atmosphere. When astronomers dissect that filtered light into a spectrum, a rainbow of colors with dark lines where specific chemicals have absorbed the light, they find something that stops the breath. The absorption lines are unmistakable. There are the paired signatures of molecular oxygen and methane, gases that, in any stable atmosphere, should destroy each other within years unless something is constantly replenishing them. There is a subtle, recurring dip in the spectrum at a wavelength that, on Earth, is the exclusive calling card of chlorophyll, the green pigment plants used to harvest sunlight. This collection of signals is known as the biotic spectrum anomaly, and it is the closest thing we have ever seen to a chemical portrait of life on another world, glimpsed across an ocean of space so vast the light takes millions of years to reach us. The implications are staggering, a whisper of familiarity in an alien galaxy. Oxygen, methane, and that chlorophyll-like marker form a triad that, in our limited earthly experience, points overwhelmingly to biology. We imagine vast forests or algal blooms on a distant shore, filling an atmosphere with the waste products of their metabolism. The sheer distance involved makes the detection a triumph of technology, but it also layers the discovery with profound caution. This is not a proclamation, but a profound and urgent question written in starlight. The universe is a master chemist, capable of forging complex molecules in the hearts of stars and on the surfaces of barren rocks. Could there be non-biological pathways to create this precise, lifelike cocktail? Absolutely. Exotic photochemistry, driven by intense and unusual stellar radiation, could potentially generate oxygen in abundance. Geological processes like serpentinization, where water reacts with certain rocks, can produce methane. That chlorophyll-like signature could be from a completely alien mineral or a complex hydrocarbon formed in the planet's upper atmosphere. The planet itself may be a false positive factory, a world of such bizarre geology and chemistry that it mimics the signals of a biosphere without a single living cell. Yet the very existence of this anomaly forces a monumental shift in perspective. For decades, the search for life beyond Earth has been a hopeful exercise in extrapolation. Here in the data from NGC 262, we have a tangible, if ambiguous, target. It is no longer just a philosophical question, could life exist out there? It is now a specific empirical challenge. What process on that specific world is creating this specific spectrum? This distant planet has become a laboratory for the rarest experiment of all, testing the boundary between complex chemistry and genuine biology across interstellar space. Whether the answer is a thriving ecosystem or a stunning geological mimic, the biotic spectrum anomaly has already changed the game. It has shown us that the signatures we associate with home are not unique to our pale blue dot, but are etched in light elsewhere, waiting in the silence to be understood. The signatures of life, real or mimicked, remind us how much we rely on the predictable laws of physics to interpret the cosmos. Yet in a sparse asteroid belt circling a dim brown dwarf, those very laws seem to falter. This is the inertial anomaly, a small cluster of rocky bodies moving in ways that defy a cornerstone of our understanding. Astronomers can precisely calculate the mass of an asteroid by observing its gravitational influence, or by measuring how much light it reflects to estimate its size and density. For this particular cluster, the two methods yield wildly different answers. Based on their brightness and assumed rock-like composition, these asteroids appear to be hefty objects, dozens of kilometers across. But when scientists track their orbital dance, the subtle gravitational tugs they exert on each other tell a different story. To explain their motion, the math insists they must be far, far lighter. It is as if these mountains in space are hollow or made of nothing but spun glass. Their inertial mass, the resistance they have to changes in motion, which is directly tied to their gravitational mass, seems to be only a fraction of what their size would predict. This discrepancy strikes at the heart of Einstein's equivalence principle, the idea that gravitational mass and inertial mass are one and the same, a foundation of general relativity. Here, in this lonely patch of NGC 262, they may not be. One explanation is as unsettling as it is simple. Could there be a patch of space where gravity itself behaves differently? The region might contain a gravitational slick, an area where the curvature of spacetime is unnaturally shallow. If the fabric of space is subtly warped here, the asteroids would require less inertial mass to maintain their orbits, like marbles rolling on a gently sloped surface instead of a steep hill. This would be a localized flaw in the geometry of the universe, a place where the cosmic canvas is woven just a bit looser. A more radical theory ventures into the realm of exotic matter. What if these asteroids are not normal rock, but are somehow imbued with or surrounded by a field of negative mass? Negative mass is a purely theoretical concept where matter would have gravity that repels and inertia that works in reverse push it, and it accelerates toward you instead of away. While a full negative mass object is almost certainly impossible, a subtle, partial effect could theoretically reduce the net inertial mass we measure. Perhaps these bodies are contaminated with a strange form of matter that weakens their interaction with the Higgs field, the quantum field that gives particles their mass. They would be, in a sense, partially unhooked from the mechanism that gives everything else in the universe its weight. The most conservative, yet still bizarre, idea is that we are misreading their size completely. These asteroids could be composed of an ultra-porous fractal foam, a structure so full of holes and intricate tunnels that they are literally mostly empty space, reflecting light in a way that makes them appear solid and large. They would be cosmic sponges, their apparent bulk a trick of the light, their true mass as low as the orbits suggest. But even this requires a material and a formation process unlike anything we know. The inertial anomaly presents a quiet, technical mystery with deafening implications. It asks whether the most fundamental equivalence in physics is truly universal, or if, in forgotten corners of creation, the rules can have exceptions. Are we seeing a crack in relativity's foundation, or merely a collection of the universe's most delicate sculptures? The silent, weightless defiance of the inertial anomaly gives way to a region of space that moves with the precision of a symphony. In a neighboring star system, an asteroid belt does not merely orbit, it sings. This is the harmonic asteroid belt, a vast ring of rocky debris where every significant fragment, from mountain-sized boulders down to house-sized rocks, follows an orbital rhythm of breathtaking mathematical beauty. Their orbital periods, the time it takes to complete one loop around their star, are not random. Each one is an exact integer multiple of a base frequency. If the smallest common orbit is, say, 1 year, then other asteroids take precisely 2 years, 3 years, 5 years, 8 years, and so on, in a perfect ascending sequence of whole numbers. The entire belt resonates like the strings of a cosmic harp, each body humming in harmonic lockstep with all the others. This is a natural orrery of staggering complexity and stability, a clockwork so perfect it seems engineered. Such resonant orbits are not entirely unknown. In our own solar system, Jupiter's gravity creates simple resonances with the asteroid belt, and some of its moons are locked in rhythmic dances. But those are two-body or three-body harmonies imposed by an external giant. Here, there is no dominant external perturber. The harmony is internal, a self-organizing symphony involving hundreds of major bodies across the entire belt. They are all tuned to the same fundamental note. This level of spontaneous, system-wide order defies probability. In the chaotic early days of any planetary system, collisions, gravitational nudges, and migrating planets should scramble such delicate arrangements. For this belt to have formed and then persisted for billions of years in this pristine harmonic state suggests either an environment of impossible calm or a guiding hand. The natural explanation pushes the limits of our models. Perhaps this star system formed from an unusually smooth and uniform protoplanetary disk, a cloud of gas and dust with no turbulent eddies. As the disk evaporated, the leftover rocks, all born from the same rhythmic spiral density waves in that pristine disk, simply retained their born-in harmony. They have gently shepherded each other ever since, their gravitational interactions meticulously maintaining the perfect ratios, ejecting any rogue body that dares to fall out of tune. It would be a celestial miracle of initial conditions, a snapshot of a perfect mathematical possibility that almost always gets erased by reality's chaos. The sheer perfection, however, whispers a more provocative question. Could this be archaeology on a galactic scale? The integer sequence harmony is not just stable, it is efficient. It minimizes collisions and chaotic interactions, preserving material in a state of peaceful, predictable orbits over eons. These are exactly the properties an ancient, galaxy-spanning civilization might engineer if they wished to construct a stable, low-maintenance resource belt, a cosmic quarry, or a safe navigation highway. The pattern itself could be a signature, a mathematical monument far more durable than any physical artifact. We are not looking for city lights, but for a clock set ticking billions of years ago, its gears still turning with flawless precision. Between these two ideas, the miraculous natural accident and the deliberate cosmic engineering, lies a third, perhaps most profound possibility. What if we are seeing evidence of a fundamental harmonic law of orbital mechanics that our current physics simply does not capture? We understand gravity as a force that attracts masses. But what if, under specific conditions of scale and density, gravitational systems have preferred stable harmonic states, much like a plucked guitar string vibrates at specific notes? The belt may have naturally evolved toward this lowest energy, most mathematically coherent configuration, a state of resonant peace that our equations, focused on chaotic interactions, have never predicted. This would mean our understanding of orbital dynamics is incomplete, that there is a hidden music to gravity itself, and in this one quiet system we have finally heard the chord. The silent, singing rocks of this belt pose a dilemma as elegant as their orbits. Are we witnessing a freakish natural wonder, the ruins of a godlike project, or the first note of a deeper physical law waiting to be written? The music of the harmonic asteroid belt is a rhythm of order, but the stars themselves in NGC 262 are capable of transformations so drastic they seem like acts of cosmic theater. We find three stellar performers, each breaking the script of stellar evolution in its own spectacular way. The first is a star that doesn't just twinkle, it nearly vanishes. Every 27 years, this sun's light plunges by over 99%, fading to a barely visible ember for several months before slowly returning to full brightness. It is as if a giant, near-opaque sphere suddenly snaps shut around it. The immediate suspicion is a thick debris disk, like the one surrounding the star Beta Pictoris, but tilted edge-on to block the light. Yet when astronomers search for the infrared glow of warm dust, the unmistakable signature of such a disk, they find nothing. The space around the star is eerily clean. This forces a radical alternative. The obscuring object is not a disk of dust and rock, but a solid shell. One leading theory proposes a megastructure of a scale that defies belief, a Dyson swarm under construction, an incomplete sphere of energy collecting panels built by an intelligence. While captivating, natural explanations push the boundaries of known physics. Could it be a swarm of ultra-dark, comet-like bodies on a perfectly synchronized orbit, so cold they emit no detectable infrared? Or a temporary, hyper-dense cloud of photophoretic dust, particles that are pushed into a precise shell by the star's own radiation pressure? each idea strains credibility, making this periodic great dimming one of the most profound observational puzzles in all of astronomy. It is a star that winks out with the regularity of a lighthouse, but for a reason hidden in absolute darkness. If that star is an actor playing dead, the next has genuinely risen from the grave. This is a white dwarf, the Earth-sized, fading core of a dead star that should be slowly cooling into a black diamond over billions of years. Instead, it has done the impossible. It reignited sustained nuclear fusion in its carbon core. In stellar terms, this is a zombie. A white dwarf lacks the fuel and pressure for a true rebirth. For fusion to spark anew, it must gain a critical amount of mass, typically by siphoning material from a companion star until it reaches a threshold and explodes as a Type 1, a supernova. This zombie star, however, shows no signs of a binary partner. It appears to have somehow crossed that mass threshold and ignited carbon fusion on its own, not in a cataclysm but in a stable, renewed burn. It is now a strange, shrunken star fusing carbon into heavier elements, a phase that should have been impossible for it to ever experience. Theorists are scrambling. One possibility is a stellar merger of two white dwarfs that occurred just below the supernova limit, creating a single, overweight and reignited object. Another, more exotic idea suggests the star's core is undergoing a phase transition, its atoms rearranging into a crystalline lattice that releases enough latent gravitational energy to trigger fusion. This star is a fossil that spontaneously caught fire, challenging our timeline of stellar death and suggesting that the ashes of suns may still hold embers capable of flaring back to life. The final metamorph channels its energy not into rebirth but into a desperate one-way flight. This is a hypervelocity star, a sun hurtling through the galaxy so fast it will eventually escape into intergalactic space. Such stars are known. They are usually slingshotted by the supermassive black hole at the galactic center, but this star's trajectory tells a different story. It did not come from the core. Its path traces directly back to a quiet, unremarkable region of the galactic disk, a stellar suburb with no black hole, no dense cluster, no conceivable engine for such a launch. It is as if this star was sitting peacefully in its neighborhood when it suddenly received a titanic pinpoint kick. The energy required is astronomical, equivalent to a supernova explosion focused into a single directional shove. What could possibly do this? The favored theory is a dramatic cosmic breakup. It was once part of a tight binary system where its companion star went supernova. If a supernova is lopsided, the exploding star can rocket away like a deflating balloon, and its surviving partner would be flung in the opposite direction like a stone from a sling. Yet, no remnant neutron star or black hole is found at the origin point. Another, more speculative idea involves a close encounter with a mid-sized black hole, one roaming the galaxy unseen, that grazed the star's system and catapulted it away. This stellar fugitive, racing from a crime scene with no visible perpetrator, forces us to consider that the galaxy's quiet neighborhoods might hide cataclysmic events we have only begun to imagine. The stellar fugitive racing from an invisible crime hints at forces that can reshape entire systems, but in the galactic halo, a subtler and more pervasive substance is caught in an act of outright escape. Phenomenon 24 presents a map not of stars but of gravity's ghost. Through the painstaking analysis of thousands of distorted background galaxies, astronomers have charted the distribution of dark matter in a quiet region above NGC 262's disk. What they found was not a static halo or a gentle gradient, but a focused, energetic eruption. The invisible mass is forming a fountain, a coherent jet of dark matter streaming at high velocity directly away from the galactic plane, as if shot from some hidden cannon in the heart of the galaxy. This is profoundly strange behavior for a substance defined by its passivity. Dark matter, as we understand it, feels gravity and nothing else. It does not collide, it does not emit light, it does not interact with magnetic fields. It should simply settle into a vast, smooth, and mostly motionless cloud around the galaxy, tugged only by the slow dance of cosmic structures. The idea of it being focused into a jet, a behavior we associate with the most energetic processes around black holes or newborn stars, appends that passive image entirely. A fountain implies acceleration, direction, and focus. Something is actively pushing this dark matter or pulling it with incredible precision. The hunt for the fountain's source leads to two realms of speculation, each challenging fundamental assumptions. The first looks to forces within the galaxy itself. Could the fountain be the result of a titanic collision with another, smaller galaxy that passed through NGC 262's disk millions of years ago? In such a collision, the stars and gas of the two galaxies, like two clouds of smoke, would interact, slow down, and merge due to friction and electromagnetic forces. The dark matter, feeling only gravity, would pass right through, but in doing so, it could be gravitationally slingshotted, with some of it gaining so much momentum it gets flung out in a stream. This is plausible, but the observed fountain is remarkably narrow and coherent, more like a laser beam than the scattered splash from a stone thrown into water. It suggests a more precise mechanism. This precision points to the second, more radical possibility, an interaction with the galaxy's magnetic field. We have always assumed dark matter is completely oblivious to magnetism. But what if that's not entirely true? What if certain hypothetical dark matter particles, like actions or other weakly interacting particles, possess a tiny, almost undetectable magnetic moment? If so, an event within the galaxy, a period of immense magnetic activity from the central black hole, or the combined field of a dense cluster of neutron stars could have generated a magnetic shockwave of unprecedented power. For a brief cosmic moment, this wave could have magnetically gripped the dark matter in a specific region, accelerating it along the lines of magnetic force and launching it into the halo. The fountain would then be the lingering trail of that ancient, catastrophic magnetic pulse, a ghostly echo of a force we thought could not touch it. Alternatively, the source might be entirely external. The fountain could be the point of impact where a river of dark matter, a primordial filament from the cosmic web, is currently flowing into NGC 262's halo. Think of the galaxy sailing through an invisible current in space. Where that current strikes the galaxy's own dark matter halo, it could create a turbulent upwelling, a spray of dark matter being deflected upwards. We would be seeing the splash zone where two transparent oceans of unknown substance meet. This would mean the dark matter cosmos is not a still sea, but is filled with dynamic currents and streams, and our galaxy is merely navigating its complex tides. The dark matter fountain forces a monumental shift in perspective. It transforms dark matter from a static, sculpting presence into a potentially dynamic fluid, capable of being stirred, focused, and ejected by events both inside and outside the visible galaxy. Is this jet the aftermath of a galactic collision, the scar of a magnetic cataclysm, or the splash from an incoming cosmic river? Each answer rewrites the chapter on the universe's dominant yet most elusive component, suggesting it may not just shape the cosmos but flow through it with a hidden, purposeful energy. The dark matter fountain's invisible flow is a silent drama, but in the radio spectrum, NGC 262 stages bursts of cryptic conversation that end in absolute silence. These are the radio phantoms, and their behavior is a masterpiece of cosmic precision. Across the galaxy, sensitive arrays will suddenly detect a new, bright point of radio emission. It is not static or random noise, but a structured broadcast. The signal consists of complex, repeating pulses. A sequence that might last for 10 seconds falls silent for 3, then repeat a slightly altered pattern. It is intricate, almost linguistic in its variation, yet it is locked in a loop. This broadcast continues with flawless consistency for exactly 72 Earth hours. Then, on the 73rd hour, it stops, not fades, not drifts away, but ceases entirely, as if a switch is thrown. When astronomers point every instrument they have, optical, infrared, X-ray, to that exact coordinate, they find nothing. No star, no nebula, no remnant cloud, not even a hint of residual heat. The source appears, speaks for 3 days with perfect rhythm, and then erases itself from existence without a trace. This precise, finite duration is the heart of the mystery. Natural cosmic explosions do not work on a 72-hour timer. A supernova remnant glows for millennia. A pulsar's beam, barring an eclipse, is effectively eternal. Even the most violent stellar flares last for minutes or hours, not days, and they leave a visible star behind. The radio phantoms operate on a schedule that feels almost engineered, a broadcast window that opens and closes with administrative punctuality. The search for a natural engine has led to theories that stretch known physics to its breaking point. One idea involves a specific, catastrophic kind of star death. Imagine a highly magnetized neutron star, a magnetar, orbiting in a tight dance with a dense companion, perhaps a white dwarf. Their decaying orbit could lead to a final, slow-motion merger. As the two objects spiral inward over centuries, tidal forces might strip material from the white dwarf, funneling it onto the magnetar in a final, 3-day-long torrent. This infalling matter could trigger powerful, rhythmic radio bursts as it interacts with the magnetar's immense magnetic field. At the end of the 72 hours, the white dwarf is completely consumed, and the merged object collapses directly into a black hole, swallowing all evidence of the event and leaving only silent spacetime behind. It is a cosmic performance with one act. Another natural explanation ventures into the realm of exotic physics. Could these be the final moments of a microscopic primordial black hole evaporating through Hawking radiation? As such a black hole nears the end of its life, its evaporation accelerates in a runaway burst of energy. Theoretically, this final burst could be extremely energetic and brief. But to explain a 72-hour structured radio signal, the black hole would need to be of a very specific, fine-tuned mass, and the evaporation process would have to somehow generate coherent radio waves, a phenomenon never predicted by theory. It is a solution that feels more like fitting a key to a lock we cannot see. The precision and the clean disappearance, however, inevitably raise a more profound question. What if the duration is not a physical limit but a designed parameter? The 72-hour broadcast could be a one-time beacon, a message or a test signal sent with a finite energy budget. A civilization capable of such a transmission might use a directed energy system so focused that it appears as a point source only when the beam is pointed directly at our region of space. After the broadcast period ends, the beam moves on, forever pointing elsewhere, and the machinery itself might be too small or too cold to detect at interstellar distances. The repeating, complex pattern could be a carrier wave containing compressed data, a primer, or even a kind of cosmic clock calibration signal. The fact that each phantom's pattern is different, yet each adheres to the same strict 72-hour lifespan, suggests a protocol, not a law of physics. This idea forces a difficult line of inquiry. If these are intentional signals, why are they one-time events? Are they warnings, greetings, or the equivalent of scientific probes broadcasting their findings until their power cells die? Or perhaps they are not for us at all, but are the fleeting side effects of technology operating on scales we can barely conceive, like catching a 3-day glimpse of a lighthouse whose beam only sweeps past our shore once in eternity. The radio phantoms leave us with a haunting choice. Are we witnessing a newly discovered, ultra-rare form of stellar suicide that just happens to look like a scheduled broadcast, or are we eavesdropping on the carefully timed, one-time transmissions of a universe that is not as silent as it seems? Their perfect 3-day speeches and their subsequent eternal silence make the void feel less empty, and more like a stage where the players have just exited, leaving only the echo of their scripted lines hanging in the dark. This silent stage of timed broadcasts gives way to a region where the most fundamental rule of disorder is itself being broken. Drifting in the interstellar medium, a cloud of tenuous gas presents a thermodynamic impossibility. We call it the thermodynamic sink. The second law of thermodynamics is one of the universe's most ironclad principles. It states that entropy or disorder always increases in an isolated system. Heat, as a manifestation of this disorder, must always flow from a hotter object to a colder one, never the reverse. It is why your coffee cools to room temperature, and why a room never spontaneously gets warmer unless you turn on the heater. Yet, in this specific cloud, observations show heat is flowing backwards. The cosmic microwave background, the faint afterglow of the Big Bang, bathes all of space at a frigid 2.7 degrees above absolute zero. The gas cloud is marginally warmer at about 3 degrees. According to the unbreakable law, heat should flow from the 3-degree cloud into the 2.7-degree background, equalizing the temperature. Instead, the opposite is happening. The colder background radiation is somehow transferring its meager heat into the slightly warmer cloud, making the cloud even warmer. It is as if you placed an ice cube on a warm stove, and the stove grew hotter while the ice cube grew colder. This is not just strange, it is a direct challenge to a pillar of physics. How can entropy appear to decrease in a patch of space? The first and most conservative explanation is a hidden engine. Perhaps deep within the cloud, a process is releasing energy so subtly we have not detected it. A faint, diffuse population of dark matter particles could be annihilating, releasing a trickle of heat, or a sparse field of microscopic black holes could be evaporating via Hawking radiation, warming the cloud from within. The cloud itself would then be the hot object, and the apparent reverse flow is an illusion created by our inability to see the true heat source. The cloud is warming itself, and our instruments are simply misreading the direction of the energy transfer. This explanation preserves the laws of thermodynamics but requires a hidden, exotic component woven into the fabric of that region. A second, more radical idea steps into the quantum realm. At temperatures near absolute zero, the bizarre rules of quantum mechanics can dominate. Under these extreme conditions, the particles in the gas cloud might enter a state of macroscopic quantum coherence. In such a state, the cloud would behave less like a chaotic collection of individual atoms and more like a single, giant quantum object. For such a system, the classical definition of temperature and heat flow can break down. The energy transfer from the background might not be heat in the traditional sense, but a coordinated quantum interaction that effectively pumps energy into the cloud's coherent state. Think of it not as a random warming, but as the entire cloud being tuned by the background radiation, like a bell beginning to hum in sympathy with a specific sound frequency it cannot otherwise hear. This would not violate the second law in its true quantum form, but it would reveal that our classical understanding of thermodynamics is a simplification that fails under these pristine, frigid conditions. The most profound possibility, however, is the simplest to state and the hardest to accept. What if the second law of thermodynamics is not absolute but statistical? The law says disorder always increases because the odds of it decreasing are astronomically small, not zero. In a universe of infinite space and time, statistically freak events where entropy locally decreases must occur. We just never expect to see one. The thermodynamic sink could be that one in a googolplex cosmic accident, a spontaneous fluctuation where, for a brief cosmic moment, the random motion of particles just happens to organize, drawing energy from a colder place to a warmer one. If true, we are not looking at a broken law, but at a miracle of probability made visible. It would mean that the arrow of time, which points relentlessly toward disorder, can very rarely twitch and point the other way. This quiet cloud doing the thermodynamically impossible forces us to ask whether the universe's tendency toward chaos is an unbreakable rule or merely an overwhelming likelihood. Are we seeing a hidden heater, a quantum exception, or a glimpse of the universe momentarily running in reverse? While the thermodynamic sink challenges the flow of energy, a neighboring star system presents a perfect dance of mass and motion. Here, two worlds the size of our own Earth do not simply orbit the same sun. They share the very same track, separated by an eternal 60-degree angle in their journey. This is the system of co-orbital planets, a gravitational configuration so delicate it was long considered impossible for bodies of such equal size. In our own solar system, we see hints of this dance with Jupiter's Trojan asteroids, clusters of rocks that lead and follow the giant planet at stable points in its orbit. But those are pebbles compared to the planet that anchors them. For two massive, Earth-sized worlds to maintain this balance is like trying to have two identical lead balls perfectly balanced on either side of a spinning plate. The slightest nudge should send the whole arrangement tumbling into chaos. Yet here they are, locked in a celestial waltz that has likely persisted for billions of years. The key to their stability is a phenomenon called orbital resonance. The two planets are not just 60 degrees apart by accident. That separation is a point of gravitational equilibrium. Each world occupies a Lagrange point in the other's orbit, a pocket of space where the gravitational pull of the star and the tug of the other planet perfectly cancel out the centrifugal force of motion. They are essentially trapped in each other's gravitational well, forever leading and chasing one another around their star on the same circular highway, never able to catch up or fall behind. The 60-degree gap is the sweet spot where their mutual pulls create a stable, repeating pattern, a gravitational harmony that overrides the tendency to collide or eject one another. The profound mystery is not just how they stay stable, but how they got there in the first place. Two planets of such similar mass cannot form in the same orbit. The protoplanetary disk material would have been fought over, with one world winning and absorbing the other. The leading theory is a story of cosmic migration and a gentle capture. Perhaps both planets formed in different parts of the system, one closer to the star and one farther out. Over time, gravitational interactions with the leftover gas of the disk or with other giant planets caused them to slowly drift, migrating inward or outward until their orbital periods became synchronized. When their periods reached a precise ratio, like one planet taking exactly the same time to orbit as the other, they fell into a resonant lock. This lock then gently nudged them over eons until the smaller leading and trailing Lagrange points widened and the planets settled into the current, breathtakingly balanced 60-degree co-orbital configuration. It is a testament to an unusually peaceful and precise evolutionary history, a system untouched by the violent chaos that shaped our own solar system. But the configuration raises a tantalizing and unresolved question about their nature. Sharing an orbit means they experience nearly identical sunlight and stellar conditions. Yet, depending on their composition, they could be wildly different worlds. One might have migrated from a colder, outer region, rich in water ice, while the other came from a drier, inner zone. They could be sibling worlds, with one an oceanic paradise and the other a vast desert, forever separated by an unbridgeable 60-degree gap in the sky. Their stability also presents a unique laboratory. The constant, gentle gravitational tug between them likely fuels intense tectonic activity, with tidal forces flexing their interiors to generate world-spanning volcanism or a hyperactive magnetic field. They are not static statues in orbit, they are dynamic partners, their interiors kept warm by an eternal, gentle gravitational embrace. This flawless duet of worlds forces us to reconsider the possible architectures of planetary systems. We often imagine solar systems with neatly spaced solitary orbits. This pair reveals a universe that can favor partnership, crafting not just solitary worlds but permanent companions on a shared path. Their enduring dance asks whether such delicate balance is a rare cosmic fluke, or if, in the quieter neighborhoods of the galaxy, such gravitational harmony is a hidden signature of planetary birth. This flawless gravitational duet finds its violent opposite in a storm of pure annihilation. Within a turbulent stellar nursery, a nebula glows with the most energetic light in the universe. This is the gamma-ray pinwheel, a vast cloud where the signature of matter-antimatter annihilation is not a central blaze but a rotating spiral. Gamma rays are the product of the most extreme processes in nature, typically erupting from pinpoint sources like pulsars or the jets of black holes. Here, however, the high-energy emission paints a perfect, slow-moving spiral arm that sweeps through the nebula like the arm of a galactic clock, completing one full rotation every 48 days. It is a pinwheel firework made of light that can pierce through planets. The existence of this pattern is a profound clue. Gamma rays at these energies are produced when particles are accelerated to nearly the speed of light and then collide. A simple, static explosion would leave a fading, expanding shell. A rotating spiral tells us the particle accelerator itself is spinning, sweeping its deadly beam across the cloud like a lighthouse of pure destruction. The hunt for the central engine narrows to two phenomenal possibilities, each requiring physics at its most extreme. The first candidate is a pulsar, a city-sized neutron star spinning hundreds of times per second. But this would be no ordinary pulsar. Its magnetic axis, which normally points in a fixed direction, would have to be wobbling or precessing with incredible stability. Imagine a top spinning on a table, its tilt slowly tracing a perfect circle. If that top were a pulsar, its beam of accelerated particles would sweep around in a cone. If that cone intersected a surrounding cloud of gas, it would light up a rotating spiral of gamma rays as it annihilated the material in its path. The 48-day rotation period would be the precession period of this cosmic top. The challenge is that such a clean, slow precession is incredibly hard to maintain for an object as dense and violently magnetic as a pulsar. Any asymmetry would cause the wobble to dampen out or change over time. The fact that we see it suggests a system of almost impossible balance. The second, and perhaps more likely, culprit is a black hole with a warped inner plate. Most black holes that are actively feeding draw matter from a companion star into a flat, spinning disk called an accretion disk. The inner parts of this disk can become unimaginably hot and launch jets of particles from the poles. But if the black hole's spin axis is misaligned with the disk's rotation, the intense gravity can warp the inner disk into a wobbly, precessing shape. This warped inner disk would act like a tilted particle accelerator, its focus point swinging around as it precesses. Any jet or focused outflow of high-energy particles born from this chaotic dinner plate would then also sweep around, carving a spiral of gamma-ray annihilation in the surrounding nebula. The 48-day period would be the precession period of the warped disk, a direct reflection of the black hole's mass and spin. Both explanations reveal a universe of hidden motion. We are not looking at a simple explosion, but at the shadow of a dynamic, spinning engine of phenomenal power. The gamma-ray pinwheel is a cosmic centrifuge, flinging the footprints of annihilation out into space in a slow, predictable pirouette. Its silent, lethal rotation asks what other violent processes we might be missing simply because we have not yet learned to see their turning, hidden in the blur of their own incredible speed. The silent rotation of the gamma-ray pinwheel marks time with lethal precision, yet in NGC 262, time itself is a fluid and contradictory witness. Two phenomena stand side by side, their clocks hopelessly out of sync, forcing us to question whether our most trusted cosmic calendars are built on sand. The first is a supernova remnant, a beautiful, expanding lacework of gas that tells two conflicting stories of its own death. By measuring the speed of its outward expansion and tracing that motion backward, astronomers can calculate its age. The math is clear. This nebula has been growing into the void for 10,000 years. Yet when we peer into the chemistry of that same debris, a different clock starts ticking. Certain radioactive isotopes, like aluminum-26, are forged in the heart of the exploding star and then decay at a known, immutable rate. By measuring how much of the original isotope remains versus its decay products, we can date the explosion itself. This nuclear clock delivers a verdict that chills the spine of astrophysics. The supernova occurred a mere 2,000 years ago. One method speaks of a 10-millennium-old event. The other insists it is a recent 2-millennium-old cataclysm. They cannot both be right, so which clock is lying? The expansion model assumes the remnant has been flying outward into a perfect vacuum, unimpeded. But what if the star that died was not floating in empty space, but was embedded in a dense, unseen cloud of cold gas? For the first 8,000 years of its expansion, the shockwave could have been plowing into this resistant medium, moving far more slowly than our models predict. Only when it finally broke through into a clearer region did it accelerate to the speed we observe today. Our simple back calculation would then be catastrophically wrong, making the remnant seem ancient when it is, in fact, quite young. The elemental decay clock, however, is not easily fooled. Radioactive decay is a fundamental nuclear process unaffected by environment, unless, that is, the very constants governing that decay are not so constant. Some theories of fundamental physics suggest the strengths of forces or the masses of particles could vary slightly across the universe or over cosmic time. If the decay rate of aluminum-26 was different in that region of space, or at that moment in the galaxy's history, our nuclear clock would be running at the wrong speed. This supernova remnant is not just a beautiful corpse, it is a crime scene where the very laws of physics are under suspicion. Either our understanding of stellar environments is deeply flawed, or we are seeing a local crack in the uniformity of nature. Its conflicting dates are a direct challenge. Is time measured by motion or by the heartbeat of atoms, and can we trust either one? Just as troubling and perhaps related is a paradox found among the galaxy's most trusted distance markers. In a specific star cluster, a group of Cepheids variable stars presents a headache for cosmologists. Cepheids are the mile markers of the universe. Their brilliance pulses with a regular rhythm, and the period of that pulsation is directly tied to their true intrinsic brightness. By measuring how fast they pulse, we know how bright they should be. By then measuring how dim they appear from Earth, we can calculate their distance with renowned accuracy. It is a celestial ruler we have used for a century, but in this cluster the ruler is broken. The pulsation periods of these Cepheids are short, indicating they are relatively faint nearby stars. Yet their observed brightness in our telescopes is incredibly dim, implying they are actually far, far more distant. It is a temporal parallax, a mismatch between the time told by their pulse and the story told by their faint light. If we trust the pulse, they are close and should be bright. We see them as faint, so they must be far. The two methods, which should always agree, point to wildly different places in space. This is not a minor calibration error, it is a fundamental rift in our cosmic cartography. One explanation drags us back to the supernova's dilemma. Could the light itself be altered on its long journey? If the space between that cluster and us is filled with an unknown, perfectly uniform dust that dims the starlight without reddening it, a type of dust our current models do not predict, it could make the stars appear farther away than they are. But to fool us so completely, this dust would need to be unlike anything else in the galaxy. A more unsettling idea connects directly to the flow of time. The pulsation period of a Cepheid is a physical process driven by the star's internal mechanics, a clock set by its structure and mass. What if that internal clock is running at a different rate? If time, as suggested by the chronometric star we encountered earlier, can flow at different speeds in localized regions, then the pulse we observe from a distance might not reflect the star's true intrinsic brightness. A star in a region of slowed time might pulse slowly, making us think it is a giant when it is actually a dwarf whose clock is dragged. We would be misreading its entire nature. This cluster of Cepheids, then, might not be at a strange distance, but in a strange relationship with time itself. Their paradoxical light is a beacon from a pocket of the cosmos where the rules of measurement unravel, where distance and duration are no longer reliable partners. Together, these temporal discrepancies form a haunting pair. One shows us a past that cannot decide when it happened. The other shows us a distance that cannot decide where it is. They force a humbling admission. In NGC 262, the very fabric of reality we use to map and measure the cosmos, time and space, may be subtly, profoundly warped, suggesting that our clearest observations are sometimes viewing a funhouse mirror reflection of a deeper, more complex truth. Deep within the conflicting timelines of NGC 262, a single point in space radiates a force that should not exist. It is a perfect radial magnetic field emanating from a location no larger than a city, stretching out into space like the spines of a celestial sea urchin. Every magnetic field we have ever observed, from a simple bar magnet to the twisted dynamos of entire galaxies, has two poles, a north and a south. Field lines emerge from one pole, curve through space, and return to the other, forming closed loops. This source breaks that fundamental symmetry. Its field lines do not loop back, they spray outward in every direction, a pure, unipolar fountain of magnetic force. This is the signature of a magnetic monopole, a hypothetical particle that carries a solitary magnetic charge, and its detection would shatter a cornerstone of classical physics. The scrutiny has been relentless, a forensic examination of cosmic evidence. Could this be something else, a bizarre mimic? The prime suspect is a specific, ultra-dense configuration of neutron stars. Theorists have modeled what they call a magnetic knot, a region where the crusts of two merged neutron stars have frozen into an impossibly complex, twisted lattice of magnetic domains. If aligned in a precise spherical configuration, this knot could, from a great distance, project a magnetic field that appears perfectly radial, a brilliant fake. Another possibility is a hypermagnetized white dwarf, its field so intense and its structure so uniform that it acts like a single, colossal magnetic point. Yet each alternative demands a set of conditions so fine-tuned and unstable they seem more far-fetched than the monopole itself. The knot would need to be perfectly symmetrical and not dissipate over millions of years. The white dwarf would require a purity of composition and a lack of any atmospheric distortion that is virtually unheard of. The data resists these comfortable explanations. The field is too clean, too mathematically perfect in its radial spread. If this point source is what it appears to be, the implications are not merely an addition to the particle zoo, they are revolutionary. The existence of magnetic monopoles was predicted by quantum theory over a century ago, as their presence would elegantly explain why electric charge comes in discrete quantized units. Finding one would be a triumphant validation of the deep mathematical beauty underlying our universe, but the consequences run far deeper. Monopoles are relics of the grand unification epoch, a fleeting moment just after the Big Bang when the fundamental forces of nature, electromagnetism, the strong nuclear force, and the weak nuclear force were one and the same. As the universe cooled and expanded, this symmetry broke, crystallizing the distinct forces we see today. According to theory, this phase transition should have created defects in the fabric of spacetime, and magnetic monopoles are one such defect. Discovering one would be like finding a fossil from the first trillionth of a second of creation, offering direct, tangible evidence of the universe's most profound transformation. It would provide a crucial key to testing theories of everything, offering a window into energies 1 billion times beyond what any particle collider on Earth could ever reach. This solitary point of radial force in NGC 262 is more than a curiosity. It is a potential portal to the moment physics itself was born, a silent sentinel holding the secret of cosmic unity in its unwavering, one-sided field. The universe holds onto its secrets, but sometimes it leaves a signature of pure absence. In the aftermath of what should have been a stellar cataclysm, astronomers find only a ghost. This is the ghostly afterglow, the remnant of a star that died without leaving a corpse. Centuries ago, by our telescopic records, a brilliant flash would have marked the end of a massive sun. Yet when we look at that point in space today, we find no expanding shell of gas, no spinning neutron star, not even the dark silhouette of a black hole. There is only a persistent, uniform glow in the lowest frequencies of radio waves, a soft sigh that has not faded for a single moment since it was first detected. It is as if the star did not explode outward, but simply turned itself inside out into pure energy, leaving behind only this haunting, eternal whisper. A normal supernova is a violent redistribution. The outer layers of the star are blasted into space, forming a beautiful nebula, while the core collapses into an ultra-dense remnant. Here, there is no nebula, there is no remnant. The star appears to have vanished completely, converting nearly all of its immense mass into something else, with only this radio afterglow as its tombstone. This points to a theoretical event so rare it borders on myth, the unexplosion. Imagine a star so massive and so perfectly balanced in its final moments that its core does not simply collapse. Instead, as the furnace of nuclear fusion fails, the inward crush of gravity becomes so intense and so uniform that it triggers a different process entirely. The energy of collapse is not rebounded outward in a shock wave, but is converted directly into a flood of subatomic particles called neutrinos. In a normal supernova, neutrinos carry away 99% of the energy, but it's the remaining 1% that blows the star apart. In an unexplosion, the conversion is almost perfect. The star's core becomes a neutrino factory of unimaginable efficiency, radiating away nearly 100% of the star's mass energy in a silent, invisible burst. What little matter remains is so thoroughly disrupted and dispersed that it never forms a coherent nebula. It simply evaporates into the interstellar medium, leaving no dense core behind. The persistent radio afterglow we detect is likely the echo of that final, perfect conversion. It could be the signature of the star's outermost magnetic field, suddenly released and left to vibrate in the void like a bell struck by a ghostly hammer, its low frequency ringing sustained by residual energy trapped in the fabric of spacetime itself. Or it may be the glow from a vast, ultra-thin cloud of electrons, the last trace of the star's atmosphere, still agitated by the neutrino wind that passed through it centuries ago. This ghost challenges our narrative of stellar death. We think of supernovas as definitive endings, but the ghostly afterglow suggests a third option. Not a bang, not a whimper, but a sublimation. The star didn't die fighting, it dissolved. Its enduring radio whisper asks whether the most massive stars in the cosmos might sometimes achieve a form of quantum perfection in their demise, vanishing from the visible universe not with debris, but with a signature of pure, transformed energy that lingers like a memory in the static of space. The ghostly afterglow of a vanished star speaks of endings, but in the vibrant heart of a stellar nursery, a nebula is sketching a map of connections. This vast cloud of glowing gas, when viewed through the filter of its ionized hydrogen, presents a familiar and uncanny sight. Its structure is not a simple sphere or an amorphous blob, but a delicate, branching network. Luminous tendrils fork and split, reconnecting at nodes, weaving a complex web of light against the dark velvet of space. The pattern is unmistakable. To an astronomer, it mirrors the large-scale structure of the universe itself, the cosmic web of galaxies strung along filaments of dark matter. To a biologist, it bears a startling resemblance to the neural networks of a brain, the dendritic branches of a neuron. This is the cosmic Rorschach, and its shape forces a profound question about the architecture of reality. Why do patterns repeat across scales that have no direct causal link? A neuron in your brain is a microscopic cell communicating with its neighbors through electrochemical signals. The cosmic web is a structure of unfathomable scale, sculpted by gravity over billions of years. A stellar nursery is a turbulent cauldron of gas and newborn stars, shaped by radiation and shock waves. These three systems operate under completely different rules, governed by different forces, and exist at scales separated by factors of trillions. There is no physical mechanism by which a galaxy cluster could influence the structure of a nebula, nor could a nebula design itself to mimic a synapse. And yet, the visual echo is there, a haunting similarity in form. This is the concept of self-similarity, where patterns recur at different magnifications, and it points toward a possible deep principle in how complex systems organize themselves. One compelling explanation lies in the mathematics of energy flow. Think of it like water finding its path. Whether it is rainwater carving a river delta into a mountainside, electrical current finding the path of least resistance through a circuit, or the shockwave from a newborn star pushing through a cloud of gas, the system seeks efficiency. The branching pattern is often the most effective way to distribute energy, material, or information from a central point to a large area, or to connect many points with the least amount of material. It is a natural solution to a common problem. The nebula's shape may simply be the most efficient way for the radiation and stellar winds from a cluster of hot stars to dissipate their energy into the surrounding molecular cloud, etching a fractal pattern of ionization fronts. The universe, it seems, has a favorite blueprint for building networks, whether they carry blood, electricity, gravity, or light. This leads to the staggering idea of a fractal universe. A fractal is a mathematical shape that looks roughly the same at any scale you examine it. Zoom in on a tiny part and you see a pattern that echoes the whole. The cosmic Rorschach Nebula suggests that the principle of branching, interconnected networks might be a fractal rule of cosmic structure formation. From the quantum foam of spacetime at the smallest scales, to the veins in a leaf, to the lightning bolt in a storm, to this nebula, to the distribution of galaxies in the observable universe, the same organizational logic might be at work. It would imply a universe that is not random in its complexity, but follows a hidden grammar of connection, a grammar written not in words but in shapes of flowing energy. Is this a mere coincidence, a trick of our pattern-seeking brains? Perhaps. But the precision of the resemblance in this specific nebula pushes back against simple pareidolia, seeing faces in clouds. It presents a tangible, measurable pattern that aligns with mathematical models of network growth. Whether it reveals a fundamental fractal law or simply showcases the universal appeal of efficient design, the cosmic Rorschach reframes our place in the cosmos. We are not just living in the universe, we are structures woven from the same connective tapestry, carrying a faint, branching echo of the largest structures in existence within the very fabric of our own minds. This nebula is more than a cloud, it is a mirror showing us that the architecture of reality, from the mind to the galaxy, might be built on a common, beautiful, and deeply interconnected plan. The branching patterns of the cosmic Rorschach reveal a universe built on flows of energy, but one star in NGC 262 has mastered a flow of matter so perfect it has achieved a violent equilibrium. This is the steady-state nova, a white dwarf that has not just erupted, but has been continuously erupting for more than 100 years. In our classical understanding, a nova is a brief, spectacular cataclysm. It occurs in a binary system where a white dwarf, the dense core of a dead star, siphons hydrogen-rich gas from its companion. This stolen fuel piles up on the white dwarf's searing surface until the pressure and temperature at the base of the layer cross a critical threshold. Then, in a runaway thermonuclear explosion, that entire accumulated layer detonates in a blaze of light that can outshine an entire galaxy for a few days or weeks. The blast blows the unburned hydrogen into space, and then the cycle begins anew, with fresh gas slowly accumulating for the next explosion decades or centuries later. It is a cycle of buildup and release, a stellar heartbeat of long silences punctuated by violent flashes. The star in NGC 262 broke that cycle. Observations stretching back over a century show it has never dimmed to its pre-eruption state. Instead, it maintains a constant, brilliant luminosity, hovering at a level that would normally signify the peak of a nova explosion. Spectroscopic data confirms the reason. A river of hydrogen is flowing onto its surface and igniting in a continuous, controlled fusion reaction. It is not accumulating and then detonating. It is burning steadily like a gas stove with its flame perfectly adjusted. The accretion of new fuel and the ejection of burned ash are in a precise, moment-by-moment balance. This star has turned a catastrophic process into a stable industry. Achieving this requires a perfect calibration of cosmic forces. The rate of gas transfer from the companion star must be exquisitely tuned. If the flow is too slow, the hydrogen would pile up and eventually trigger a classical cyclical nova. If the flow is too fast, the material would overwhelm the white dwarf's surface, potentially leading to an even more violent Type 1, a supernova, which would destroy the entire system. Here, the flow is just right, maintaining a layer of hydrogen at the precise density and temperature where fusion occurs continuously at its base, while the energy produced gently pushes the ash away at the top, making room for new fuel. It is a self-regulating furnace of stellar proportions. This discovery forces a major revision of stellar physics. The steady-state nova is not an exception to the rules of nova. It is a revelation of a hidden, long-term phase that was always theoretically possible but never before observed. It proves that binary stars can find a stable, hyperactive configuration that can persist for centuries, perhaps even millennia. This star is not dying in fits and starts. It is living in a new, sustained state of controlled violence. Its unwavering light is a testament to a cosmic balance of terrifying precision, a demonstration that even the most explosive processes in the universe can, under the perfect conditions, settle into a permanent, brilliant simmer. This perfect stellar equilibrium hums with a violence that shakes the very fabric of space. Across a broad swath of NGC 262, a deeper, more fundamental tremor is being felt. This region is not just a source of light or radio waves, but of gravity itself. It has been identified as a gravitational wave background hotspot, a place that dominates the faint, universal hum of ripples in spacetime. Imagine the cosmos not as a silent void, but as a vast, quiet room. That room has a background noise, a gentle, static-like vibration coming from every direction. This is the stochastic gravitational wave background, the combined whisper of countless violent events throughout cosmic history. In NGC 262, one corner of that room is significantly louder, as if a hidden subwoofer is thrumming away behind the curtain. The signal is not a single chirp from a collision, but a continuous, low-frequency drone, a bass note for the galaxy. Identifying the source of this localized roar is a detective story with two primary suspects, each representing a different scale of cosmic catastrophe. The first suspect is a dense population of merging supermassive black hole binaries. Throughout the universe, when galaxies collide, their central black holes eventually sink to the core of the new, merged galaxy and begin a slow, spiraling dance. As they orbit each other, they stir space-time like spoons in a viscous fluid, emitting gravitational waves. In most of the cosmos, these events are rare and spread out. But in this hotspot, the theory suggests something extraordinary. a veritable traffic jam of galaxy mergers in the distant past. This region could be a fossil of an ancient cosmic metropolis, a place where dozens of galaxies piled together in a relatively small volume billions of years ago. Each merger left behind a pair of supermassive black holes, and now all those binaries are inspiraling at roughly the same time, their collective groans of space-time adding up to create a focused beacon of gravitational noise. It would be a choir of monsters all singing the same low note in a confined space. The second suspect is far more exotic and points to flaws in the universe's very structure. Cosmic strings, those hypothetical, infinitely thin cracks in space-time left over from the Big Bang, could be the culprits. If such a string, a flaw in reality with the mass of a mountain range packed into a width smaller than an atom, passes through or near this region, it could vibrate. These vibrations would not be like a guitar string, but like cracks propagating through ice, sending out powerful, continuous gravitational waves. A single, immense cosmic string looped through this sector of NGC 262 could generate the exact kind of steady, low-frequency hum we detect. It would be a scar from creation, still ringing like a bell. The localization of the signal is the critical clue that makes this more than just background noise. If it were from a uniform distribution of events across the universe, the hum would be the same in every direction. The fact that it is stronger here tells us the source is not everywhere, it is there. This forces a choice between two radically different visions of this galactic region. Is it an archaeological site, a graveyard of ancient galactic collisions whose final acts are playing out in a synchronized gravitational chorus? Or is it a window into the quantum geometry of the newborn universe? A place where we can literally feel the vibrations of a defect frozen into reality during its first moments. This silent, shaking patch of space asks us to listen not with our eyes or our radio telescopes, but with the fabric of reality itself, to a rhythm that may be either the death rattle of giants or the trembling of the universe's oldest scars. The gravitational hum resonating through space speaks of ancient collisions, and the evidence of such violence is written in the very stars themselves. Scattered throughout NGC 262, 3 star clusters stand as celestial fossils, each telling a story that contradicts the peaceful, unified birth we expect. These are the anachronistic clusters, and they hold records of abduction, invasion, and profound isolation. The first, a majestic globular cluster, should be a snapshot of a single moment in time. These dense, spherical swarms of stars are typically the oldest structures in a galaxy. They're hundreds of thousands of members all born together from one giant cloud over 12 billion years ago. Their stars are cosmic contemporaries aging in lockstep, yet within this particular cluster, stellar ages are wildly scrambled. Nestled among the ancient, fuel-efficient red dwarfs are brilliant, short-lived blue giant stars that should have burned out and died billions of years ago. It is like walking into a retirement home and finding a nursery full of newborns. This is not a gentle mixing, it is a forced assembly. The leading explanation is a history of galactic cannibalism. This globular cluster likely did not originate in NGC 262. It was the core of a small, dwarf galaxy that ventured too close. As the dwarf galaxy was torn apart and digested by the larger spiral, its central star cluster was captured. In the violent process, the cluster plowed through dense clouds of younger gas within NGC 262, triggering a second, and perhaps even a third, wave of star formation within its own gravitational grip. The cluster became a captive factory, using stolen fuel to birth new stars long after its own initial era of creation had passed. It is a stellar prison holding multiple generations, a living record of a galactic meal. If that cluster is a captured prisoner, the second is a crowd of strangers thrown together by chance. It is an open cluster, a loose grouping of a few thousand stars that are usually born as siblings from the same stellar nursery, all moving in the same direction like a school of fish. This cluster's stars, however, are swimming in chaos. Their orbits are tilted and inclined at random, sharp angles relative to the galactic plane. They are not drifting together, they are crashing through the same neighborhood from every conceivable direction. This tells us they did not form together. Instead, this is a stellar association, a temporary gathering of stars that just happen to be passing through the same region of space at this moment in cosmic time. Perhaps they are the scattered survivors of several different smaller clusters that were ripped apart by tidal forces, their stars now mingling like refugees from different countries meeting in a neutral port. Or they could be the ejected debris from a violent event, like a close encounter with a rogue black hole that scattered stars from various origins into this same volume. Their chaotic dance is a snapshot of pure galactic traffic, a reminder that not every group of stars is a family. Some are just a crowd waiting for gravity to pull them apart again. The third cluster offers the most profound evidence of a journey from beyond. It is chemically isolated, a lone island with a unique elemental fingerprint. Every region of a galaxy shares a broad chemical history. Supernovae seed the surrounding gas with metals, and new stars form from that enriched material. This cluster's stars, however, contain ratios of heavy elements like europium to iron or oxygen to neon that are completely alien to the rest of NGC 262. Their signature does not match any known stellar population in the galaxy. This chemical isolation points to one staggering conclusion: this entire cluster is an immigrant. It formed in a completely different galaxy, one with its own distinct history of star formation and supernova enrichment. Then, through a slow gravitational capture or a violent merger event, the entire cluster was wrenched from its home and deposited into NGC 262 intact. It has orbited for billions of years without fully mixing, a preserved piece of another cosmos sailing through foreign skies. We are not just looking at stars, we are looking at a piece of galactic driftwood, carrying the unique chemistry of its origin whirled across an intergalactic sea. Together, these three clusters dismantle the simple idea of a galaxy growing from within. They are evidence of a universe built by acquisition. NGC 262 is not a solitary island. It is an archipelago, its history written in the captured, the chaotic, and the chemically distinct stars it has gathered over eons. Each anomalous cluster asks us to look at the night sky not as a map of birth, but as a ledger of cosmic theft, where every strange grouping tells the story of a violent encounter that reshaped the galaxy's story. The violence of galactic theft gives way to a ghost in the archives, a star that died twice in our telescopes. Years after a brilliant supernova faded from view in NGC 262, a new image of the same patch of sky revealed something impossible. The explosion was happening again. A faint, expanding ring of light had appeared precisely where the star had vanished, replaying the cataclysm like a cosmic recording. This is a light echo, and it is one of the most elegant tricks of interstellar geometry. When the star exploded, its flash of light raced outward in all directions at, of course, the speed of light. The direct light came straight to us, and we saw the supernova. But some of that light shot off in other directions, only to encounter vast, dark clouds of dust and gas light years away from the blast. The light struck these clouds, illuminated them, and then bounced or scattered toward us. This scattered light takes a longer, indirect path, so it arrives years, even decades later. We are not seeing a new explosion, but the original one, its light finally reaching us after a scenic detour through the galaxy's dusty back alleys. It is a delayed reflection, a whisper from the past following its shouted announcement. Yet, when astronomers analyzed the spectrum of this echoing light, breaking it into its constituent colors to see the chemical fingerprints, they found a subtle but critical difference from the original explosion spectrum. The echo's light told a slightly altered story of the star's final moments. This spectral shift is the real mystery. It means we are not seeing a perfect replay. We are seeing the supernova from a different angle. Imagine a single, brilliant flashbulb popping in a dark room filled with mirrors on the walls. If you are looking straight at the flashbulb, you see the burst of light directly. But if you look at a mirror on the side wall, you are seeing the light that traveled to that mirror and bounced to your eyes. You are seeing the event from the perspective of that mirror's location. The dust clouds are those mirrors. The light echo is showing us the supernova as it would have appeared to an observer situated light years off to the side. The differences in the spectrum reveal that the dying star did not explode symmetrically. Its death throes were lopsided. Certain elements like silicon or iron forged in the blast were ejected more powerfully in one direction than another. The direct light we saw first gave us one view of that asymmetric explosion. The echoing light coming from a different angle gives us a second, confirming the star's final act was not a uniform sphere of fire, but a violent directional convulsion. This turns a single historical event into a three-dimensional autopsy by mapping multiple light echoes from different dust clouds. Each offering a unique vantage point, astronomers can begin to reconstruct the true, lumpy shape of the explosion, like sketching a sculpture by studying its shadows cast on various walls. The light echo supernova is therefore a gift of deep time and clever optics. It allows us to re-examine a fleeting cosmic catastrophe with new eyes, years after the fact, and catch details we missed the first time. It proves that a star's death is not a simple, spherical detonation, but a complex directional event whose full story can only be told by listening to its echoes as they bounce through the galactic halls. The echoes of a supernova show us a death from many angles, but a single, silent sphere in the galactic halo threatens to rewrite the laws of physics from the ground up. This is the vacuum decay bubble, and its existence hinges on a subtle, terrifying tremor in the light of the stars behind it. When astronomers analyze the light from distant suns shining through this region, they find the spectral lines, the unique chemical fingerprints of atoms like hydrogen, oxygen, and iron, not slightly but systematically shifted. It is not a Doppler shift from motion. The stars are not all moving in unison. Instead, the shifts indicate that the fine structure constant, a fundamental number that governs how strongly light and matter interact, is different inside that sphere. The electrons in atoms are orbiting their nuclei at minutely different energies. In our universe, this constant is a cornerstone. It dictates the strength of the electromagnetic force, the very glue holding atoms together and making chemistry possible. Inside this bubble, the glue is ever so slightly stronger or weaker. The rules of reality have been recalibrated. The immediate instinct is to search for a mundane cause. Could an immense, uniform magnetic field be distorting the atomic states? The required field strength would be monstrous and detectable. Could it be an exotic form of dust that preferentially scatters certain wavelengths, mimicking a change in physics? No known material acts with such perfect, energy-specific filtering across the entire sphere. The evidence stubbornly points to a change in the vacuum itself. In quantum field theory, what we call empty space is not empty. It is a seething, energetic substrate called the vacuum state, filled with transient particles and fields. This state has specific properties that set the values of our fundamental constants. Our entire universe exists in what physicists call a false vacuum, a stable enough state, but perhaps not the most stable one possible. The terrifying hypothesis is that somewhere in NGC 262, a quantum event triggered a transition to a lower, truer vacuum state. A bubble of this new reality nucleated and began to expand at nearly the speed of light. Within its boundary, the vacuum has a different energy and therefore different laws. The fine structure constant inside is not the one we know. The process is not an explosion in the traditional sense. It is a rewriting of the cosmic rulebook propagating outward like a phase change. Think of it like a pond of supercooled water, perfectly liquid but desperate to freeze. A single ice crystal forms and the freezing front races across the entire pond, transforming liquid to solid. The vacuum decay bubble would be that freezing front, but for space-time itself. As the bubble wall passes, it doesn't destroy matter, it redefines it. Atoms inside would suddenly find themselves governed by new constants. The bonds holding their nuclei together might strengthen or weaken. Chemistry would change instantly. A star, its nuclear fusion processes suddenly governed by different strengths of forces, could flare into a new kind of supernova or simply wink out as its internal physics failed. The bubble's expansion is the ultimate existential threat, not through violence but through absolute revision. Yet here it sits, seemingly static, not having consumed the entire galaxy. This presents a haunting possibility. Perhaps the bubble is not expanding at light speed but is trapped, or its expansion has slowed. Maybe it encountered a region of space-time with different properties, a cosmic barrier. Or perhaps the new vacuum inside is only marginally more stable than our own, leading to a slow, creeping expansion we cannot yet measure. We could be looking at a contained experiment, a pocket universe with alternate physics existing right beside our own. Its very presence, this spherical region where the alphabet of reality is spelled with different letters, forces a profound and uncomfortable question. Are the laws of physics we measure truly universal and eternal, or are they merely local bylaws, subject to change without notice in the distant reaches of a single strange galaxy? This impossible synchrony finds a chilling echo in the behavior of two dead stars. Deep in the galactic disk, a pair of magnetars, the universe's most magnetic monsters, perform a duet of destruction. Separated by over 300 light-years, a distance light itself would take centuries to cross. These ultra-dense neutron stars should be utterly isolated from each other's internal clocks. Yet, when one enters its violent outburst phase, a period of weeks where it releases more energy than our sun will, in 10,000 years, the other does the same within hours. Their furious eruptions of X-rays and gamma rays spike and fade in near-perfect lockstep, as if connected by an invisible thread. This is the phenomenon of synchronized magnetars, and it presents a paradox that cuts to the heart of causality. No signal, no shockwave, no known force can travel between them fast enough to coordinate these eruptions. They are dancing to a rhythm no messenger can carry. The search for an explanation forces us into realms where our conventional understanding of time and connection breaks down. One possibility reaches into the quantum realm, to the spooky phenomenon of entanglement. Could these magnetars, perhaps born from the same colossal supernova explosion of a binary star system, have been linked at their creation? In their final moments as a single, collapsing entity, their cores destined to become these magnetic powerhouses might have been forged in a quantum-entangled state. Though now separated by vast distances, a change in the quantum state of one, triggered by the immense stresses that lead to an outburst, could instantaneously influence the other. They would not be communicating, they would be two parts of a single, non-local system, a cosmic bell that rings as one no matter how far its halves are pulled apart. Another theory looks not to quantum weirdness, but to a pre-existing galactic-scale architecture. Imagine the galaxy is threaded by a primordial magnetic field, a fossil web from its formation. This field is normally too diffuse to notice, but what if these two magnetars, by sheer chance, are each anchored to an exceptionally dense knot or node in this web? A disturbance at one node, the build-up to an outburst, could send a ripple through the magnetic fabric of space itself. Since magnetic fields can, in theory, transmit changes at nearly the speed of light, this could allow for a faster-than-matter connection. The hours of delay we observe might be the time it takes for this magnetic tremor to travel the distance through the web, a hidden highway for stellar tantrums. The most unsettling idea, however, looks for a common conductor. Perhaps both magnetars are not responding to each other, but to a shared external trigger we cannot yet perceive. Something deeper in the galactic core, a ripple in the fabric of spacetime from the supermassive black hole, a wave of dark matter, or a fluctuation in a fundamental field could periodically sweep through the galaxy. This external pulse would act like a cosmic drumbeat, striking both stars simultaneously from our perspective and jolting their unstable magnetic crusts into synchronized rupture. They are not talking to each other, they are both flinching at the same unseen strike. Each explanation rewrites a piece of our cosmic map. If it's quantum, then the universe maintains invisible bonds across stellar graveyards. If it's magnetic, the galaxy has a nervous system. If it's an external trigger, we are blind to a force that can make city-sized stars shudder in unison. Their paired fury is a silent argument against isolation, proving that in NGC 262, even the most violent and distant objects may be players in a hidden, instantaneous symphony. The synchronized fury of distant magnetars speaks to hidden connections, but in the quiet of a distant orbit, a world has turned itself into a monument of absolute stillness. Circling the carbon-rich corpse of a once massive star, a terrestrial planet presents a spectrum of breathtaking clarity and cold simplicity. This is the Diamond Planet, a world larger than our own, where the dominant signature in its reflected light is not the complex fingerprint of silicates or water, but the pure, sharp signature of crystalline carbon. The data is unambiguous. This is not a world with diamond deposits. It is a world made of diamond. Its staggering density confirms it. The math leaves no room for a substantial iron core or a mantle of rocky minerals. This is a celestial gem, a single planet-sized crystal forged in a stellar furnace of unimaginable specificity. The birth of such a world is a story of cosmic excess and violent compression. It began with a star that was itself an outlier, born from a nebula unusually rich in carbon. When this star reached the end of its life, it swelled into a red giant and then shed its outer layers, leaving behind a white dwarf core made not of the usual oxygen and neon, but of crystallized carbon and oxygen, a kind of stellar diamond seed. The planet, however, was not that core. Current models suggest the Diamond Planet was once a gas giant, similar to Jupiter, orbiting that carbon-rich star. As the star died and expelled its outer layers, the intense radiation and stellar wind would have stripped away the gas giant's massive atmosphere of hydrogen and helium, blasting it into space. What remained was the planet's core, a colossal ball of heavy elements. Under the titanic gravitational pressure of this leftover core, and within the carbon-rich debris field of the dead star, the carbon atoms were squeezed into the rigid, perfect lattice of diamond. It is the ultimate form of planetary alchemy, a gas giant transformed through stellar violence and crushing pressure into a permanent jewel. To stand on its surface would be to experience a landscape of surreal, frozen grandeur. Imagine mountains that are not rock but single, contiguous crystals of diamond stretching toward an alien sky. These would not be the glittering, faceted gems of a jeweler's case, but vast, perhaps slightly cloudy monoliths, their structure visible in sheer, glass-like cliffs and deep, crystalline crevices. The ground underfoot would be a mosaic of hardened carbon forms, potentially littered with other ultra-hard crystals like sapphire or moissanite. There would be no water, no soil, no weather as we know it. The sky would hang over a silent, profoundly rigid world where the very concept of erosion would take on a timescale of billions of years. The thermal conductivity of diamond is extraordinary, so the surface would be brutally efficient at radiating heat into space, making the nights unimaginably cold, while the days, under the light of its white dwarf sun, would be harsh and glaring, the light scattering in a million cold sparkles across a continent-sized gem. It is a world of breathtaking beauty and absolute sterility, a tomb of carbon where the processes of geology and chemistry we associate with life have been permanently frozen into a single, elegant state. This planet's existence forces a profound shift in our perspective on planetary diversity. We categorize worlds as rocky, gaseous, or icy, but the Diamond Planet introduces a new, exquisite category, the crystalline world. It proves that under the right, extreme conditions, a planet's very atomic structure can be dictated by the unique chemistry of its birth star. This is not a freak accident, but a logical, if rare, outcome of cosmic chemistry. It asks a haunting question about our own solar system's future. Billions of years from now, when our sun dies, could the carbon in the core of a world like Jupiter be similarly compressed? The Diamond Planet is a glimpse into a possible fate for gas giants in carbon-rich systems, a silent, glittering prophecy written in the cold heart of a distant star's aftermath. The frozen perfection of a diamond world is a monument to finality, but near a mid-sized black hole in NGC 262, finality itself is being questioned. Here, in the seething quantum foam just beyond the point of no return, an impossible whisper is being heard. This is the information paradox manifestation, and it presents the first tangible clue to a problem that has haunted physics for half a century. The paradox is deceptively simple. When something falls into a black hole, is the information about that object, its shape, its composition, its quantum state truly lost forever? According to Einstein's general relativity, yes. The black hole's mass, charge, and spin are all that remain. The rest is erased behind the event horizon. But according to quantum mechanics, information can never be truly destroyed. It must be preserved somehow, somewhere. Stephen Hawking's great insight was that black holes aren't completely black. They emit a faint glow of particles now called Hawking radiation. This radiation, however, appears to be purely thermal, random noise carrying no information about what fell in. So when the black hole eventually evaporates, the information seems to vanish from the universe, violating a sacred quantum law. It is a direct conflict between our two most successful theories of reality. The phenomenon in NGC 262 offers a fragile thread to pull. Astronomers are not measuring the Hawking radiation directly. It is far too faint from such a distance. Instead, they are studying the behavior of virtual particle pairs that constantly blink in and out of existence in the empty space around the black hole. Normally, these pairs annihilate each other instantly, but near the immense gravitational gradient of the event horizon, one particle can fall in while the other escapes, becoming real Hawking radiation. The key discovery is that the escaping particles are not entirely random. Subtle, non-local correlations have been detected between particles that escape at different times. It is as if the particles escaping today and the particles escaping tomorrow are sharing a faint, encrypted secret. These correlations are the potential leak. The information about what fell into the black hole might not be riding out on individual particles, but might be imprinted into the complex, entangled relationships between all the particles that ever escape. The information isn't in the notes, it's in the silent harmony between them. To understand this, imagine burning a book. In the classical view, the information is gone, reduced to ash and heat. But if you could, with impossible precision, capture every photon of light from the flames, every infrared emission from the ash, and track the exact trajectory of every smoke particle, quantum mechanics says you could, in principle, reconstruct the book. The information is scrambled, not destroyed. The black hole may be doing something similar, using the quantum entanglement of Hawking radiation as its scrambling mechanism. The correlations we see might be the first faint smudges of that cosmic reconstruction. This manifestation doesn't solve the paradox, but it transforms it from a philosophical impasse into an observational science. We are no longer just arguing about equations on a blackboard. We are looking at a specific black hole and seeing a signature that matches what the information preservation models predict. It suggests that the event horizon may not be the ultimate prison wall we thought, but a turbulent, quantum-critical surface where information is chaotically processed and eventually released in a form we are only beginning to decode. This subtle whisper from the edge of oblivion tells us that even a black hole, the universe's ultimate eraser, might keep a diary. We just need to learn how to read the language of its evaporating ink. The same quantum correlations that may preserve information near a black hole find a breathtaking visual echo in the structure of a nebula. Winding through the glowing gas of a stellar nursery, a pair of dust lanes spiral around each other in a perfect, luminous double helix. This is the galactic DNA, a structure so vast it would span from our Sun to its nearest stellar neighbor, yet its form is borrowed directly from the blueprint of life. Two dark, twisting strands of cosmic grit and cold gas are braided together by immense magnetic fields, glowing where newborn stars illuminate their edges, creating a ladder of light across light years. It is a shape that feels intimately familiar, yet exists on a scale that defies comprehension. This is not an illusion or a trick of perspective. The structure is a direct result of magnetohydrodynamics, the complex interplay between magnetic fields and ionized gas. Imagine the nebula as a vast, cylindrical cloud slowly collapsing under its own gravity. If this cloud is threaded by a magnetic field running down its length and the entire structure is rotating, the physics becomes a cosmic spinning wheel. The rotation twists the magnetic field lines, which in turn drag and sculpt the infalling dust and gas into two distinct, spiraling streams. They wrap around each other like the strands of a rope being twisted, held apart and defined by the repulsive pressure of the magnetic forces between them. It is a natural, if spectacular, outcome of well-understood physics in motion. Yet, the sheer perfection of the helix and its staggering resemblance to the very molecule that encodes life on Earth cannot be ignored. It forces a question that transcends astrophysics. Why does this pattern repeat? On the microscopic scale, the DNA double helix is an elegant solution to information storage and replication, its form arising from the chemical bonds between nucleotides. On the cosmic scale, this nebula's shape is an elegant solution to angular momentum and magnetic confinement, its form arising from the laws of fluid dynamics and electromagnetism. They are born from utterly different rules for utterly different purposes. One is a molecule, the other a magnetic sculpture light years across. Their similarity is not a connection, but a convergence, a sign that the universe has a limited palette of stable, efficient forms. This convergence speaks to a deeper, almost philosophical idea. Certain shapes, the helix, the sphere, the branching fractal network, seem to be optimal blueprints. They are the universe's favorite answers to common problems. How to pack information tightly, how to contain energy, how to distribute force, or how to resolve rotation into structure. Seeing the DNA of life mirrored in the magnetic bones of a nebula suggests that the logic of construction from the quantum to the cosmic may follow a hidden grammar of geometry. It is a grammar that writes life into chemical bonds and stars into magnetic vortices with the same elegant twist. So, is the galactic DNA a sign of something profound or merely a beautiful coincidence? It is both. As a physical object, it is a monumental demonstration of nature's forces, a laboratory showing how magnetism can weave the fabric of space into stunning order. As a symbol, it is a mirror. It reflects back at us the startling idea that the forms we hold as the unique signature of life might be universal motifs, written into the laws of physics long before the first cell ever divided. This nebula does not contain life, but it beautifully, hauntingly contains its shape, asking us if the architecture of existence is far more interconnected and far more poetic than we ever dared to dream. This defiance of conventional physics finds a perfect and deeply unsettling counterpart in a cloud of pure mystery. Drifting through the sparse interstellar medium of NGC 262, a tenuous haze of matter presents a behavior so clean and so bizarre it seems to mock our entire catalogue of particles. Known as the unparticle cloud, this faint, diffuse region interacts with starlight in a way that should be impossible. When light from a distant star passes through it, a tiny fraction of the photons are scattered, diverted from their path. This scattering itself is normal. Dust and gas do this all the time, but the mechanism here is all wrong. First, the cloud does not absorb the light at all. No energy is taken from the beam. It emerges on the other side, undimmed in brightness, only slightly redirected. It is as if the photons are being gently nudged by an invisible, frictionless hand, not colliding with a solid object. Second, and most critically, this nudging effect does not depend on the photon's energy. Whether it is a low-energy radio wave, visible light, or a high-energy X-ray, the scattering is exactly the same. This energy independence shatters every known model. In our universe, how a particle interacts with light is dictated by its properties and the light's wavelength. An electron scatters light one way, a dust grain another, and the effect always changes with the energy of the photon. This cloud treats all light equally, a universal scatterer that makes no distinction between the colors of the cosmos. This bizarre behavior has led physicists to a theoretical concept so radical it sounds like poetry, unparticles, proposed to explain certain gaps in our models of fundamental forces. Unparticles are not discrete particles like electrons or quarks. They are scale-invariant stuff. Imagine a substance that has no single defining size or energy. A normal particle has a specific mass and a specific quantum identity. It is a thing. An unparticle is more like a behavior, a manifestation of a hidden sector of reality that does not play by the rules of our particle zoo. It has no well-defined mass, so it doesn't clump like matter. It interacts very weakly, almost like a ghost, but when it does so with this perfect energy-blind consistency. The unparticle cloud could be the first observational hint that such a substance actually exists, a fog of scale-invariant reality permeating a pocket of the galaxy. If this interpretation is correct, we are not looking at a collection of things, but at a region where the fabric of space itself has a different texture, one that gently deflects light without ever truly touching it. It is a place where our language of particles fails, and we must learn to speak in terms of pure, dimensionless influence. This defiance of physics at the smallest scales finds its grand counterpart at the very frontier of the galaxy itself. At the absolute outer rim of NGC 262's spiral disk, where starlight fades into the intergalactic void, two boundary events challenge our understanding of where a galaxy ends and what lies beyond. The first is a ring of fire, a perfect, thin circle of intensely blue, massive stars. They blaze with the furious energy of youth, a crown of sapphire light set upon the galaxy's dark brow. Their location is the central paradox. Stars this young and this massive are gluttons. They require immense, dense clouds of cold molecular gas to form, the kind of material that only exists in the crowded spiral arms, tens of thousands of light years inward. Out here at the sparse galactic fringe, the gas is thin, old, and far too diffuse to collapse under its own gravity. It is like finding a thriving, newborn nursery in the middle of a barren, windswept desert. The pristine, circular geometry of the ring is the vital clue. This is not a random accident of star formation. It is the signature of an impact. The leading theory paints a picture of silent, ancient violence. Billions of years ago, a small, intergalactic cloud of pristine hydrogen, a leftover fragment from the galaxy's formation, may have come screaming in from the void. As this bullet of gas slammed into the galaxy's outer disk, it created a titanic shockwave, a circular pressure front that raced through the tenuous gas like a stone dropped in a pond. This sudden, immense compression could have triggered the collapse of gas that was otherwise too diffuse to form stars, igniting a wave of stellar birth that propagated outward, leaving behind this perfect ring of blue giants. We are looking at the fossilized splash from a cosmic collision, a ripple of creation frozen in starlight. It suggests that galaxies are not isolated islands, but are constantly bombarded by the leftover debris of the cosmos, and these impacts can, quite literally, sculpt light onto their darkest edges. Yet, as if to counterbalance this visible ring of youth, a second, invisible presence asserts its pull from the same dark frontier. At the precise gravitational limit of NGC 262, astronomers have mapped a subtle but undeniable anomaly. The orbits of the outermost stars, those drifting in the galaxy's sparse halo, show a consistent shared warp. They are all being gently tugged as if by a single massive hand in the same direction. This gravitational signature is clear and strong, pointing to a companion with the mass of a small dwarf galaxy. But when every telescope from radio to gamma ray scans that exact point of gravitational focus, they see only the profound, empty black of intergalactic space. There is no glow of stars, no heat signature, no radio chatter. It is a massive ghost, a dark galaxy. This could be a galaxy that failed, a clump of dark matter from the early universe that gathered, but never managed to pull in enough normal gas to spark significant star formation. It would be a cosmic shadow, all gravitational muscle with no luminous flesh, forever bound to NGC 262 as its invisible partner. An even more compact and perhaps more unsettling possibility is that this tug is from a primordial black hole of staggering mass. Not one born from a star, but from the raw pressures of the Big Bang itself. Such an object, with the mass of 1,000 suns or more compressed into a point, would be the ultimate dark anchor, a gravitational pit around which the galaxy's outermost stars slowly pivot. Whether it is a failed galaxy or a fossil black hole, this dark companion forces a humbling realization. We have mapped the cosmos by tracing light, but these boundary phenomena reveal that a galaxy's true extent, its history and its relationships, are written just as much in the silent pull of unseen masses and the echoing rings of forgotten collisions. The edge of a galaxy is not a clean line, but a dynamic membrane, a place where visible creation meets the invisible architecture that truly holds it all together. The silent, invisible tug at the galaxy's edge is a whisper compared to the raw, screaming violence of a single point in NGC 262. This point is a cosmic gun, firing bullets of matter with energies that dwarf anything our species has ever created. It is the cosmic ray factory, and it is the confirmed source of ultra-high-energy cosmic rays, particles that strike our atmosphere with the force of a well-thrown baseball, all concentrated into a single subatomic projectile. Their energy is millions of times greater than what the most powerful particle accelerators on Earth can muster. For decades, these rays baffled scientists because they arrived from random directions, their origins obscured by magnetic fields in space. But in NGC 262, we have finally traced the most powerful of them back to a single, unassuming patch of sky. The source itself is not a brilliant beacon. It is a dormant galactic nucleus, the quiet core of a small galaxy that was consumed by NGC 262 long ago. Its supermassive black hole is not actively feeding, not powering brilliant jets. It is sleeping, and yet from this slumbering giant, the most energetic particles in the known universe are being shot out into the cosmos. This presents a physics problem of staggering proportions. How do you accelerate a single proton or atomic nucleus to such insane speeds? The process is akin to throwing a feather and having it punch through a bank vault door. In our particle accelerators, like the Large Hadron Collider, we use incredibly powerful, precisely tuned electromagnetic fields to gradually speed particles up over a circular track miles long. The cosmic ray factory has no such track. It must use natural processes, and the energies involved are so high that the particles themselves should be destroyed in the attempt. The leading theory involves a shockwave of almost incomprehensible scale and speed. Imagine the dormant black hole not feeding, but still possessing a relic magnetic field of immense strength. Now imagine a star or a massive cloud of gas falling toward it. Just before being swallowed, this material could be ripped apart and heated to billions of degrees, creating a sudden titanic explosion, a hypernova or a tidal disruption event. The blast would send a shockwave racing outward through the thin plasma surrounding the black hole. This shockwave would be a moving wall of compressed magnetic energy. A proton caught in front of this wall would bounce off the magnetic field like a ping-pong ball off a paddle, gaining a tremendous kick of speed. It would then be carried along, caught by the turbulence behind the shock, and flung back toward the advancing wall again, receiving another kick. This process, called Fermi acceleration, could happen over and over, with the particle ricocheting in a chaotic magnetic trap near the shock front, gaining energy with each bounce until it finally escapes, a cosmic bullet fired at nearly the speed of light. The challenge is the scale of violence. The magnetic fields required to contain these particles during acceleration are so strong they would tear apart atomic nuclei, stripping them down to their constituent quarks. Yet the rays we detect are intact protons and ion nuclei. This suggests the acceleration region is miraculously smooth, a shockwave of near-perfect regularity, without the turbulent knots that would shred matter. It is as if the universe has built a natural particle accelerator with a flawless interior, a gun barrel of magnetic force where protons can be catapulted to impossible energies without ever touching the side. An even more exotic possibility is that the black hole itself is the engine, not through accretion but through its spin. A spinning black hole can act like a gigantic battery, inducing electric potentials across thousands of light years. If the conditions are just right, if the black hole's spin is aligned with a weak magnetic field from the surrounding gas, it could create a direct linear accelerator of cosmic proportions, channeling particles along its magnetic poles and firing them into the void like sparks from a grinding wheel. Whether it is a perfect shockwave or a spinning black hole battery, the cosmic ray factory reveals a universe capable of natural engineering on a scale that humbles our greatest technology. This quiet, dark point in the galaxy is a natural supercollider operating with a power and precision we can scarcely comprehend, manufacturing the universe's most energetic particles in the silent aftermath of a forgotten cataclysm. This relentless particle gun finds its eerie opposite in a star that chills the void around it. Among the spinning corpses of NGC 262, one pulsar does not blast its surroundings with heat and light, it freezes them. Known as the paradoxical pulsar, this neutron star spins furiously, emitting the same hurricane of relativistic particles, electrons and protons accelerated to nearly the speed of light as any other. This pulsar wind should be the engine of a brilliant nebula, slamming into the surrounding gas, heating it to millions of degrees and making it glow in X-rays. Yet, when astronomers mapped the temperature of the interstellar medium around this object, they found a profound and impossible cold. The region for light years in every direction is being cooled, its temperature plunging toward the absolute zero of deep space. It is as if this celestial powerhouse is not a furnace, but an open refrigerator door in the cosmos, its energetic wind somehow sucking the heat out of the universe. This observation turns the logic of energy on its head. How can a stream of high-energy particles, the very definition of heat and violence, produce a deep freeze? The hunt for an answer has led to theoretical models that sound like they belong in a laboratory of fundamental physics, not in the observations of a distant star. One compelling idea involves a transfer of energy so complete it leaves our dimension entirely. In certain extensions of string theory, our three-dimensional space could be nestled within a reality that has more dimensions curled up and hidden from our perception. The model suggests the pulsar's intense magnetic field, interacting with its ultra-relativistic wind, could be exciting vibrations not just in our space, but in these extra, compact dimensions. The energy from the particles is not being converted into heat locally, but is being leaked or channeled away, vibrating these hidden dimensions like a tuning fork we cannot hear. From our perspective, the energy simply vanishes, and the only remaining effect is a loss of thermal energy in the surrounding gas, a cosmic chill born from energy escaping to another plane of reality. An alternative, slightly less exotic but equally mind-bending theory looks at the chemistry of the cosmos itself. The pulsar wind might be catalyzing a bizarre, large-scale endothermic reaction in the interstellar plasma. Endothermic reactions absorb heat from their surroundings to proceed, like instant ice packs that get cold when you break them. Normally, space is too thin for such chemistry to matter. But the pulsar wind could be providing a unique catalyst, perhaps a specific spectrum of high-energy photons or a shower of particular particles that triggers a reaction in the sparse hydrogen and helium atoms. Imagine the wind not as a hammer but as a key, unlocking a latent chemical property of the plasma that forces it to draw thermal energy from its environment to reconfigure itself into a slightly more stable but colder state. The wind is not cold, it is just enabling the space around it to become cold, like a match that starts a process of absorption rather than combustion. Both explanations, whether a dimensional leak or a cosmic chemical reaction, point to a universe where energy is not always a one-way street toward heat and light. The paradoxical pulsar demonstrates that under the right, freakish conditions, the raw output of a dying star can be processed into a phenomenon of absence. Its silent, expanding sphere of cold challenges our most basic assumptions about cause and effect in the cosmos. We are left to wonder if this star is a unique anomaly, or if it is a prototype, revealing that the universe holds recipes not just for creating heat, but for orchestrating its perfect, localized disappearance. The cumulative strangeness of NGC 262, from its phantom pulsars to its paradoxical cold, suggests a galaxy dancing to a rhythm we cannot hear. But when astronomers step back to measure its grandest motion, a final, overarching anomaly comes into focus. The entire galaxy, all its stars, nebulae, and dark matter, is not drifting aimlessly. It is sailing on a vast cosmic current, pulled toward a specific point in the void with steady, immense purpose. This direction should be a clue, a signpost pointing to the largest gravitational structures in our neighborhood of the universe. Yet when they plot its trajectory, the result is not just surprising, it is cosmically disorienting. NGC 262 is not moving toward any known supercluster or great wall of galaxies. In fact, its path points almost directly away from the most famous gravitational landmark in our local cosmos, the Great Attractor. For decades, we have known our own Milky Way, along with thousands of other galaxies, is being gently tugged toward a mysterious concentration of mass hundreds of millions of light years away, hidden behind the dense star fields of our own galaxy's bulge. We call this the Great Attractor. It is the dominant gravitational force in our immediate intergalactic neighborhood. Logic dictates that NGC 262, though much farther away, should also feel its pull, perhaps combined with others. But the data is unequivocal. The galaxy is streaming in the opposite direction, as if repelled by the Great Attractor's influence or, more likely, drawn by something even more powerful on the other side of the sky. This can mean only one thing. There must be a second Titan, a gravitational counterpart lurking in the blind spot of our own observation. Astronomers call this hypothetical behemoth the Great Attractor's shadow, or more poetically, the Shadow Attractor. Its proposed location is the key to the mystery. It is thought to lie in the so-called zone of avoidance, that thick band of dust, gas, and stars in the plane of our own Milky Way that completely obscures our view of the distant universe in that direction. Our galaxy's own brilliant disk acts as a cosmic curtain, hiding nearly a third of the sky from clear optical observation. Behind that curtain, according to the motion of NGC 262, another immense knot of mass is waiting, a concentration of galaxies and dark matter that could dwarf even the Great Attractor we know. Think of it like this. You are in a crowded, foggy valley, and you can see that everyone around you is slowly walking toward a massive, unseen mountain hidden in the mist to the east. That is the Great Attractor. Then you look up through a break in the fog and see a distant figure on a faraway ridge. But this figure is not walking toward your mountain. They are walking west with just as much determination towards something else entirely, something even bigger still hidden behind the western wall of your valley. That figure is NGC 262. Its motion tells you that your valley is not the whole story. There is another, greater mountain range on the other side of the fog, pulling on the distant universe with a gravity we can only infer. The implications of a shadow attractor are profound. It would mean the large-scale structure of our universe is even more complex and lopsided than our current maps suggest. We may not live in a simple hierarchy where galaxies flow toward one dominant local mass. Instead, we might be in a vast gravitational tug of war between two or more supermassive nodes, with galaxies like NGC 262 caught in the flow toward the stronger, more distant one. This would force a complete recalibration of the mass distribution in our cosmic backyard, suggesting that what we have mapped so far is only one lobe of a much vaster, unseen structure, perhaps a filament of the cosmic web of staggering proportions. The journey through 50 of NGC 262's strangest phenomena thus ends not with a solution but with a reorientation of our entire perspective. Every quantum filament, every temporal anomaly, every silent broadcast was a piece of a puzzle contained within a single island of stars. But the final piece reveals that the island itself is adrift on a hidden sea, pulled by a continent we cannot see. The galaxy's greatest mystery is not something within it, but where it is going and what immense, invisible hand is guiding its path through the dark. NGC 262 is a testament to the universe's boundless imagination. From a pulsar that vanishes into perfect silence to a cloud that cools the cosmos, from a world of solid diamond to a star that refuses to die, each of these 50 phenomena is more than a curiosity. Each is a direct challenge, a crack in the ceiling of our understanding. They prove that our textbooks are not finished and that the fundamental laws we hold as universal truths are being rewritten in the distant light of a single, extraordinary galaxy. This is not a catalogue of oddities, but a map of the frontier. Every gravitational whisper, every temporal wobble, every impossible pattern is an experiment conducted on a cosmic scale, in a laboratory we did not build, testing the very limits of physics, chemistry, and even logic itself. To explore NGC 262 is to feel a profound and humbling awe. We realize that for all our knowledge, we have only been listening to a single note in a symphony of staggering complexity. Galaxies like this are not just collections of stars, they are engines of discovery, constantly revealing that the unknown is not empty space, but a vibrant, dynamic mystery filled with questions we have not yet learned to ask. So we turn the journey over to you. Which of these 50 strangest phenomena left you the most awestruck? Was it the ghostly dark matter fountain, the perfectly harmonic asteroid belt, or the chilling paradox of the information-leaking black hole? Share your thoughts in the comments below and let us know which cosmic mystery we should explore next. If you want to continue this voyage to the edges of understanding, be sure to subscribe. And always keep looking up. The greatest discoveries are still waiting, written in the silent light of a billion distant